Everyone getting sevens. Everyone in this live gonna get 7. Okay, so I just literally messaged 20 minutes ago on the bulletin and asked which past paper we should do, and you guys said chemistry. So that's the vibe. So today we're going to be doing a chemistry standard level paper 1A time zone 3. I don't think we've done this one together. I don't think I've done this past paper myself. So we're going to be doing it together for the first time and giving opinions. And we can go ahead and get started if you guys are ready. Someone asked, will you do physics past paper? I'm going to try. So essentially, we had a setup where we asked a different tutor to do the physics past paper live, and that's why we sent that form out. But then they canceled. So I'm going to have to pick up the pace and try to see if I can do it myself. What year is this? This is November 2025, time zone 3 SL. So the first question says, I'm going to read it and then I'll answer your questions. The first question says, what is the name of this change of state? Wow, what a fire question. If this showed up on my exam, I'm eating it up. And I always tell my students this tip, and I'm going to tell you guys this tip so you always get it. We got some C's in the chat. Let me open up that mark scheme because I haven't done this past paper. Okay, we got C's in the chat. Let's see. So I'm going to give you guys a tip. We have a sublimation, okay? So actually, I hate to break it, guys. It's not. But I'm going to give you a tip so you never make that mistake ever again, okay? This is what I tell the crash course students and what I told them this year. And this is what I'm going to... Gas solid, I hope, is sublimation. No, it's actually not, guys. It's not. Careful. So I know that... Let's break it down. Let's break it down. So solid to liquid, we know this. What is this? Solid to liquid. Ice to water is melting. Okay? We know this. Melting. Liquid to gas is what? Evaporation. We know this. Okay? So I have solid to liquid to gas. Okay? This is melting. This is evaporation. We know this. But then there's those tricky ones. And the tricky ones is essentially the gas to solid and the solid to gas. And those are the tricky ones that IB will put on your exam. This is a common question. It has shown up before, I think like 2 or 3 times in the past years. I'm going to give you the hint. So S to gas, because you go from solid to gas, you're subliming, like sublimation. So because solid starts with an S and sublimation starts with an S, you go from solid to gas. And then the other tricky one is gas to solid will be the opposite, which is deposition. So actually the answer is B. Hopefully that helps you memorize it for the future, guys. So anytime you see this on your exam, and by the way, they've only ever asked sublimation and deposition because generally condensation and freezing is too easy. Melting, evaporation, those are all too easy. So what they'll do is they'll ask sublimation and deposition. And so I want you to think, okay, when it's sublimation, sublimation starts with an S. And so I'm going from S to gas. And then just remember that deposition is the opposite. Okay? First question wrong. Let's go. Exactly. But now hopefully you're not going to get it wrong. Does that make sense, guys? Was that a helpful memory tip? What paper is this? This is the time zone 3 November 2025. SL. Let's go ahead and... Yay. Okay, I'm glad, Marta. Bear with me, guys. I haven't done this past paper before, and I'm trying to read your comments. So if I miss it, repeat it. What is the best evidence that energy levels are closer together as distance from the nucleus increases? I've never seen this type of phrased question like this. It's never been phrased like this. So I'm going to tell you which ones are repeats because I think it's really helpful also for revision knowing which ones are repeat. This is a repeat IB question. This has definitely shown up before. This one, in terms of the content covered, it is a repeat. It is an old syllabus question. We know this, but it's never been phrased like this before. So this one definitely would have gone right if you've just been spamming past papers. This one's a bit difficult. I'm going to give you guys a couple seconds. Which subject? This is chemistry. All right, let's see. Is this bio? No. So solid to gas sublimation. Exactly. Think S solid, S sublimation. Melting, deposition, AAA. Okay, I think I got all your questions. Should we set a like goal? Can we reach 30K likes? Let's see if we can. Okay, Rolo said D. Someone said B. Someone said C in the chat. All right, all right. How do I join the crash course? You can just join the crash course by going on e7ibsciences.com. If you guys want me to show you like the crash course demo, let me know and I can share my screen and show you the crash course if you want. Maybe because if the distance increases, then the first ionization decreases. I actually fell for it. Okay. So C is the correct answer, and we're gonna go look through it now. I haven't read properly the answer options, but that's what it says in the mark scheme. Let's have a look. It says, what is the best evidence that energy levels are closer together as the distance from the nucleus increases? So this is just testing a very common thing that you must know. Where must you know this, guys? You must know this when you're drawing the energy level ionization hydrogen spectrum. So maybe you're familiar with this. N is equal to 1, N is equal to 2, N is equal to 3. You must know certain things for your exam. What are the things you need to know? You need to know that N equals 1 is the UV region. N equal 2 is the visible region. Does anyone remember what N equal to 3 is? Do some active recall in the chat, because you must know the first three energy levels, what they do. And you must know as well something that happens. You must know that as you get further and further away from the nucleus, essentially you have the convergence, it's called convergence, very key word, of energy levels. And that's what they're asking. What evidence shows this? Very good job, guys. N equals 3 is the infrared level. Okay? You also need to know other stuff like what is absorption, what is emission. Again, this is just overall topical review that you should review on your own. But for this question, they're asking about that convergence that's happening and what is the evidence for that. So hydrogen has a line emission spectrum in the UV, visible, and infrared regions. That is true, but actually hydrogen has a line emission. This is not, first of all, this is not the best evidence, so 100% incorrect. And we know that um, you don't need to know about if hydrogen has a specific emission spectrum in the UV visible or infrared regions. We know it also has multiple. First ionization energies decrease down a group. So down a group, guys, what's happening? What's happening down a group? My radius is increasing. I want you to think in your exam, whenever you see ionization energy, automatically think of radius. Those two are the things that should be tied together. So when you have a high ionization energy, what is ionization energy? Ionization energy is the energy required to remove 1 mole of electrons from a gaseous atom. So imagine I'm holding, this is my atom, and this is my electron, my pen. Now, how much energy does it require to remove this electron is dependent on my radius. Because if my atom is really, really small and my radius is really, really small, I'm holding my electron so tight. And so I require more energy to pull this electron out. If my radius is loose, my electron is loose inside. This is really weird motions, but really loose in my radius. So my ionization energy is going to be much lower because it's easier for me to pluck that electron out. And that's what you should be thinking always. So to get the mark in your exam, whenever you see ionization energy, you reference it directly to the radius. And so down a group, because my radius increases, can anyone tell me what's going to happen to my ionization energy, guys, based on that logic? I'm sorry, Peach. Can anyone tell me? So if the radius increases, what happens? The ionization energy decreases. Very good. Okay. So first ionization energy decreases down a group. This is a true statement. Is it evidence to show that convergence happens? This convergence happens in the emission spectrum? No. Okay. C says lines in the emission spectrum converge at higher energy. That's what they're referencing. Okay. In an emission spectrum, this is exactly what we drew here. We see that the energy levels, as you go from n is equal to 1, remember n is equal to 1 is closer to the nucleus, closer to that proton neutron center, is this n is equal to 1. And as you go further away, your energy levels start converging, and you must draw this. You must draw the energy levels closer in your exam to get full marks. Okay? So that's why C is the correct answer. First ionization energy increases across a period. Well, generally, yes, increased across a period because we know the radius also decreases across a period, but that's not good enough evidence. Now, I hate this question. I would assume that multiple people got this question wrong on their exam just because it's not so clear, but hopefully that made sense a bit more, guys, based on the explanation I've given. Radius decreases, I require more energy. Exactly. Very good job. Okay, are we happy with this? Or should we move on? Des. Okay, I'm so glad. Let's do a mole question. So generally, I want to tell you this tip because I think it's really helpful. Generally, in the old syllabus, what they always asked is that they always asked mole questions in the beginning. The first question in every single Chem Pass paper is moles. Okay, now in the new syllabus, what they're doing is something different, and you have to pay attention to this. In M25, this is what's been happening. They are in like this awkward phase in which they're switching from old syllabus content to new syllabus content. So in M25, they can't really like go full ham in new syllabus. They can't really jump and just start asking about like separation techniques, and they can't start asking about like lithium batteries and stuff because they had to give students leeway. So we see in M25 actually, the past papers were quite similar for chemistry and bio, less so bio, to the old syllabus. Now in N25, they're being more bold. And they're basically telling you guys, they're hinting at teachers and they're hinting at examiners and they're hinting at students, lock in on the new syllabus content. And so what we're seeing is that in N25, they're pushing the mole questions further because now they're referencing the organization of the new syllabus and they're starting with separation techniques, homogeneous and heterogeneous mixtures, and the changes of state. So what should you predict as the first question in your exam? What I'm assuming in the M26 exams, it's going to be separation mixtures, change of state, all this new syllabus content in terms of like equations, essentially the first thing you're going to see in the syllabus guide. Okay. And so that's why we see the mole question a bit further, just to give you guys context, because I feel like context as well in terms of analyzing past papers is actually quite helpful. So it says how many ions are present in 0.2 moles of ammonium sulfate. I'm going to give you guys a couple seconds to calculate this and then we'll do it together. And I'm going to go ahead and read your comments because I see I'm missing some. My exam in 2 weeks, my teacher hasn't finished half the bio content. Help. Girl, run to our crash courses, please, I beg you. We do these crash courses where we teach the syllabus in 5 days. Every single syllabus content is covered, every single one. And we explain it, and we do past papers with you, and we give you cheat sheets, everything. Could you do Chem HL paper 2? Of course I can. Of course, this is an SL paper. I'm happy to do an HL paper. I'm going to try to go live every day, guys, now that the crash courses are over because I'm just more free. What are we thinking for question 3? Anyone have any idea? I'm failing chem because my exam got cancelled. It sucks. Oh no, I'm so sorry. If you want, message us. I know people in the UAE are quite struggling with like studying. Message us and we'll see how we can help you guys. Are you ever going to do other topics? Yes. So I teach math, chemistry, and bio, and we have crash courses for math, chemistry, and bio. The crash course has a fee, right? Yes, it does. It has a fee. So you pay for like hours of teaching. If you want, I can show you guys a demo. I just don't want to interrupt the past paper, but if you want, I can show you like how the crash course looks like. Okay. I'm so lost. I don't know how to solve that. No worries, guys. We're going to break it down. Let's go ahead. So, in the crash course, sorry to bring it up, but in what you should do in your head is organize essentially the two different types of mole questions. Now, they could ask you to find the moles of atoms, molecules, or ions, or electrons, or protons, or neutrons. And I want you to divide them two things in your head. So, now we know to find the moles, atoms, ions, any moles of anything like this, we do moles times Avogadro's number. Okay, and that will give you that exact number of molecules. Now, be very, very careful, guys. I cannot stress this enough. This is very common IB exam question. Very common. If they say how many ions there are, you have to take a step further. You cannot just do moles times Avogadro's number. Does anyone know why? Well, if they give you ions in the exam, if they give you the word atoms in the exam, if they give you the word electrons in the exam, if they give you the word protons in the exam, if they give you distinct things, like distinct structures, ions, atoms, electrons, protons, not only do you have to do the moles times Avogadro's number, you have to do a step further and multiply by the ions present in the molecule. Okay? Whenever you see how many molecules there are or how many formula units there are, then you can just leave it as it is. So based on this, guys, what can we do? We take the number of moles, which is 0.2, and we multiply that by Avogadro's number, and then we times it by how many ions are present. It's as simple as this. Now, how many ions are present, guys? How much do you see? How many do you see? You think there's 3, right? Because there's 1 SO42 minus. There's 2 times ammonia. Okay? So there's an overall of 3. So I just have to take this and times it by 3. So my answer is going to be C. Are we happy with this, guys? Wait, in what case do we just do moles times Avogadro's number? Very good question. So wait, I don't know if I can pull up my stoichiometry slides from the course because I have like this exact, wait guys, can I share my screen? Would that bother you? Give me a second. I have like this table basically that shows exactly which case you do which. Do you want me to share my screen and show that or just do the past paper? What would you guys prefer? Anyway, the cases are when it says molecules in the exam, when it says molecules, you should just do show please. Okay, then give me 1 second. I'm gonna share my screen now. Give me 1 second. So in the cases where you have molecules, formula units, this is when you essentially don't have to multiply by anything. If you have ions, atoms, here. Thank you so much for the gift. I really appreciate it. You are the best. Okay, for some reason it's not letting me share. Oh, hell no. Oh, hell no. Hello? Ah, there you go. Okay, so I'm gonna show you now. So I'm gonna go to, where is it? Where is it? Chemistry. Okay, perfect. Hopefully you guys can see. So these are the crash course slides. I'm just gonna scroll to moles. You can see my screen, right? Hopefully I don't get in trouble. I'm sharing these slides. Uh-oh. Yes, okay, perfect. I'm gonna scroll now. Separation mixture. Okay, here it is. Okay, so the cases in which you multiply are this. Limiting excess, no, 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 no. How much are the crash courses? Depends if you're SL or HL. Damn, where are these slides, bro? I promise, guys, there's here. They're here. Give me a second. Bear with me. Bear with me. Okay, there you go. Okay, I found them. We're all good to go. Can we continue past paper, please? Of course. Okay, so maybe take a screenshot of this, guys, quickly. So when do you not multiply is when they say molecules, particles, or formula units. Those are when you don't have to multiply. Okay? And then when you do multiply is when they mention atoms, ions, electrons, protons, and neutrons, elements in a compound. Are we good to go with that? Are we happy? Can I remove my screen now and continue with the past paper? Let me know in the chat. But yes, so you'll see that the crash courses are perfect. Okay, let's go ahead and continue. Nice. My teacher did not bug. Yeah, girl. You will find out that even in bio, it's crazy how much your teacher doesn't teach. Anyway, so if you follow those tables I just showed you, those two tables I showed you, it's gonna be so easy doing the mole questions because then you just remember in your head, um, okay, I gotta multiply now. Also, guys, I can give you a discount code for the crash course, M2610. You can use that. That just got released the other day. Okay, this says what is the volume in decimeter of ethane gas produced when 0.2 moles of ethene reacts with zero point 0.4 moles of hydrogen gas? Sorry, decimeter of hydrogen gas. All volumes are measured under the same conditions. Wow, fire question, comment question, repeat question. This should be answered very quickly. If this showed up on my exam, I'll be happy. How much is it for SL? Let me check quickly, guys. I don't remember off the top of my head. And while I'm checking, you guys can go ahead and just answer in the chat. Okay, there's a B. Easy. Ooh, okay. We're on fire today. Nice. So what do we assume, guys? Once you so it's 135 for SL and for HL it's 200. What do we assume, guys, when they're giving you decimeters under standard temperature pressure? We assume that the volume is equal to what? Who remembers? Do some active recall in the chat. The volume is equal to the decimeter is directly equal to the moles, right, guys? Okay, exactly. Very good job. Very good job. And so in my question, I'm already thinking, okay, the decimeter is equal directly to the mole. So I don't got to do much. I just got to plug in my values. So it's asking me, what is the volume of ethane gas? This is my question mark. This is what I'm trying to find. Produced when 0.25 moles of this react with zero point 0.4 moles of this. Okay, to find the moles of the final, I have to apply the moles of the initial in my reactants. And so step one for me is to find the limiting. 0.25 divided by its coefficient is going to be 0.25. 0.4 divided by its coefficient, which is 2, is going to be 0.2. Which one is the smaller one? The hydrogen is the smaller number, and therefore my hydrogen is my limiting. Are we happy with how I found the limiting, guys, or would you like me to explain it um, in a slower step? Exactly, very good. Find the limiting reactant. Nice. A. You are correct. A is the correct answer. Be very proud. And so I'm producing, okay, 0.2 moles of exactly ethane gas. And that's why A is the correct answer. The reason why that is because the ratio between hydrogen gas and this ethane is 2 to 1. And so I'm producing half the amount of hydrogen I'm producing. Okay? Someone said no in the chat. Could you just please clarify if you want me to no as in re-explain or no as in move on? Thank you guys so much for almost 10K likes. And Peach, thank you so much for all the gifts. You're such a cutie. All good. Okay, perfect. Let's go ahead and move on. It says a fixed volume of an ideal gas initially at 30 degrees Celsius with a pressure of P was heated to 60 degrees Celsius. What is the resulting pressure in Pascal? Again, repeat question, old syllabus. If you're doing your past papers, this should be a simple one to do. I hate pressure questions. They're answered horribly in exam by students. It's just conceptually hard. But is it something that's like new syllabus or something that's out of the blue that's shocking? It's not. Okay, that's why we just gotta do them and practice them. And actually, in what I've done for the crash course students is I compiled all the difficult pressure questions, because there was one of them that showed up. Guys, heads up! I'm gonna tell you now, so you guys can look out for it. I don't remember what year it was, but it was insane. It was like two canisters of gas and one opens and one closes. Yeah, bro, it was deadly. So that was the only exception that was like random pressure question that came out of nowhere for the chemistry students. Does the entire world start exams on Monday? I'm not sure actually. PV equals nRT question. Close. You are correct, kind of. It's actually PV1. So Avogadro's law. T1 is equal to P2 V2, but it's derived in the same by the same formula. Okay, so let's have a look. So essentially it's saying a fixed volume of gas. So step one with these questions, guys, always, always, always write your equations. This equation I'm writing here is PV1, V1, over T1 is P2, V2 divided by T2. Then I'm going to cancel out the constant variable. What's the constant variable? My volume. So step two is cancel my constant variable. And then I'm going to apply my equation. It's saying at 30 degrees Celsius, by the way, can I just keep it as 30 degrees or do I have to convert it to Kelvin? Who knows? There's only one thing in your whole IB chemistry syllabus that you can just keep as Celsius. Exactly, very good. You have to convert it to Kelvin. The one thing that you can only keep as Celsius in your whole IB chemistry syllabus is your Q equals MC delta T. This is the only thing you can leave as Celsius in your whole chemistry syllabus. So I have my 3303, which is just this in Kelvin, and I have with the initial pressure of P. And then I need to find P2. What's P2 once I change to 60 degrees? So 60 plus 273 to get 33 Kelvin. Okay, and I'm going to try to see what's happening to P2. Okay, I'm going to try to cross multiply. So when I cross multiply, essentially what do I get? I get that 333, oops, P2 is equal to 303 P. No, I did something wrong. 333 P is equal to 303 P2. And then I'm going to go ahead and divide my 303 to the other side. And I get that P2 is equal to 333 divided by 303. And that's like 1.0999. Once again, you have your calculator, and I just like doing it like this so I can conceptually understand it. And so I know that the new pressure, the resulting new pressure, which is what they're asking me, is it half of P? Is it a little less than P? Is it a little more than P? Or is it 2 times than P? Which answer are we happy with? That's so weird. What is weird? You can keep. You can technically keep because it's a conceptual question, but no, do not keep. Please do not keep. And do not have that a little more. Exactly. Very good job, guys. So C is my correct answer. Are we happy with conceptually how I've explained this? And do you think you guys are able to get this in your exam? Please let me know. Weird that Q equals MC delta C. Okay, it is weird, but it's actually not weird. And I can explain why while we go over this one. Yes, yay. I'm so glad, guys. I thank you. I understand now. I'm so glad. I'm really, really proud of you guys. Which paper is this? This is time zone 3 November 25. That was a horrible pen to write in SL. What are the electron domain geometry and molecular geometry of sulfur dichloride? This one, you just gotta draw it out. I hate these questions. They take forever. If you are bad at drawing, skip this question in your exam. Remember, every single MCQ question in your bio, in your chemistry exam is worth 1 mark. And so if something takes you longer, I generally, I like skip it. And actually what I did for my exam, guys, a little helpful tip while you guys are trying to solve this, is that I skipped my first few questions because in my exam I was like so incredibly stressed, and so I skipped the first few questions because I just they look so incredibly hard, and then I skipped to a question that I was more comfortable with, and that's when I actually started my exam. I didn't explain that very well, but let me know if you want me to explain that technique a bit better because it's actually a really helpful exam technique that I still use in med school today. Okay, you can keep it the same because Kelvin and Kelvin have the same increments. Exactly, very good, Leia. So this is referencing the Q equals MC delta T conversation we were having. This is the only place in IB chemistry where you can keep delta T in Celsius. The reason why that is because it's a change in temperature. Change in temperature, no matter if you do 60 degrees Celsius minus 30 degrees Celsius or 333 Kelvin minus 303 Kelvin, that's still going to give you the same value of 30 because change in temperature has no values. And so this is the only formula in the whole exact IB chemistry where you don't have to convert to Celsius. Does that make sense? When did you take your exams? I took them in 2023. Your hockey better than my chem tutor. Oh, that's so sweet. I tutor chem as well, and we tutor chem. Guys, if you like my teaching, you're gonna go crazy for Minna, who is the original crash course tutor, who literally taught me what I know. And if you're really liking this teaching and you want help with chemistry, do check out our crash courses because we teach you the whole syllabus. Okay, what were we thinking for this one? No one kind of answered it in the chat. Do you guys just want to do it together? I love you guys too. Mwah. Think you understand it now. Perfect, perfect, perfect. Makes sense because it helps you set in the exam mood by starting with something comfortable. Exactly, Peach. That's exactly the method. Okay, let's just do it together. Molecular geometry are my weaknesses. Okay, let's break it down. Zoja says A. Someone says B. Let's have a look. So there are exceptions that you need to know for your exam in terms of molecular geometry, but this is not an exception, so we can just go ahead and draw it. And please do check out your exceptions because they're very, very common. IB loves bringing up the exceptions, like the silicon oxide. That one was an exception that showed up on the May 2025, and that was deadly. No one got that correct, basically. But let's go ahead and draw the structure. So step one is to always find the number of valence electrons in sulfur and chlorine. I'm going to search it up quickly because I don't have my handy dandy periodic table. If anyone knows off the top of their head the valence electrons, I would greatly appreciate. Okay, thank you very much. So I think sulfur has 6. 1, 2. Yeah, sulfur is like oxygen has 6. Oh no, 5 you said. 1, 2, 3, 4, 5. Yeah, 6. So sulfur has 6. Don't worry. And chlorine has 7. This I know because chlorine is a halogen. Nice. And so I have 2 times chlorine, so I have to take that into account. So I have 6 plus 7 plus 7. 7 plus 7 is 14. 14 plus 6 gives me 20. And so then I have 20 divided by 2. Okay, so sorry, I jumped a bit quickly. But first, I get the valence electrons, step 1. Step 2 is to divide by 2. Okay, that's going to be step 2. Divide by 2. And then step 3 is to get that number, which is 20 divided by 2 is 10. Once you have that value of 10, I know I need to draw 10 sticks around my silicon chloride. So I draw my silicon, which is my central, and then I draw my chlorine, 1, and my chlorine, 2. And I need to draw exactly 10 sticks around this structure. So I already have 1 and 2, and then I have 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now, every single chlorine is satisfied. They have all 4 bonds. Every single sulfur is satisfied. So we're good to go. And so now we can just do the electron and molecular domain geometry. Does anyone remember the difference between electron and molecular? This is a very important concept, commonly tested. Once again, I did mention, but this is a repeat question. If you've been doing a bunch of past papers, you know that this is a common question. Okay, so people are saying B or D, A or C. Isn't the line worth 2? Exactly. Very good mention that you say that because that's why we divided by 2. Each line is worth 2 electrons, and that's why we divide by 2. Okay? Someone said being B or D. All right, I think you guys just don't want to draw this out, which is completely fine. The answer is B. So essentially, electron domain geometry is talking about the different number of electron regions. So how many electron regions do I have? I count the sticks and the lone pairs. So I count 1, 2, 3, 4. And therefore, it's tetrahedral. And that's why my answer is either A or B. Molecular geometry is actually what it looks like what is actually the 3D structure of it. And we know that once you have 2 sticks like this and 2 lone pairs, it actually forms bent. And For this, I would just really recommend you just spam flashcards. We have flashcards for our crash course students for this. Create your own, find some online, do whatever you need to do. Just spam flashcards. But hopefully the drawing made sense, guys. So actually, the answer is B. Are we happy with that? Thank you so much for 13K likes. You guys are the best. 7, you gotta find which. Oh yeah, which one is polar? Repeat question, not new syllabus. This one's chill. This one's nice. Do you guys want to do this together to draw it out together, or are you guys just bent because lone pair would repel, be linear if expand octet, have 3 lone pair to 1? Wow, very good. Okay, someone's saying A. Careful, guys. What are the two characteristics that you have in order for something to, or some? What are the two things that you must have in order for something to be polar? You must have difference in electronegativity. Nice, very good. And one more thing, the more important one. Very good. Difference in electronegativity. And one more thing, guys. What's that second thing? Anyone know? It has to do with geometry, dipole moments. Yeah, dipole moments. Good. Yes, guys, close. Electronegativity is all the dipole moment, the partial charges. Yes. And does anyone else remember something else? Very good job. Asymmetry. Exactly. Nice. Symmetry. Nice. Difference in electronegativity. Bonds cancel out. Exactly. Basically, the second thing I was referencing is the symmetry. And that's what's going to actually get you the answer here. So here we see we have carbon, fluorine, and fluorine, and fluorine. We know carbon and fluorine have a difference in electronegativity just because fluorine is the most electronegative and carbon is not that electronegative. We know that. But what do we have here, guys? We have symmetry. And so we have negativity coming from all of the fluorines. Okay. But all the dipole moments are pointing inwards. Okay. Oh, sorry, they're pointing outwards. They're going from positive to negative, but it doesn't really matter. The point is that the force of the charges is symmetrical. And so it actually becomes non-polar because you have that symmetry. Okay? Does that make sense? That's why A is actually incorrect. So if you said A, it's incorrect. Let's have a look at CO2. CO2 would look, so carbon has 4 valence electrons. I'm just going to draw it quickly, guys. Let me know if you want me to slow down. Carbon has 4 valence electrons. Oxygen has 6. 6 times 2 is 12. 12 plus 4 gives me 16. 16 divided by 2 gives me 8. Okay, so I need to draw 8 sticks. Once again, let me know if I need to slow down, please. 1, 2, 3, 4, 5, 6, 7, 8. Carbon is not satisfied. So what ends up happening is that you have the carbon-carbon double bonds. Okay? And so we have CO2. Now, CO2, your central carbon is going to be positive, and your oxygens are going to be negative. What do we see here, guys? If my dipole moment goes from positive to negative, I have my dipole forces going from positive to negative. This is the direction of my dipole moment. Is there symmetry? There is symmetry, right? This is a symmetrical molecule. Therefore, this is non-polar or less polar. Exactly. Very good job, guys. So B is not the correct answer. Let's have a look at the other ones. NH, NBr, NBr. Let's have a look. It cancels out. Very good job. I'm so proud of you guys. Br is 7. 7 times 3 gives me 21. Nitrogen, off the top of my head, I remember it's 5. If anyone else can remember as well. No, it's 1, 2. It's 5. Yep, 5. Has 5 valence electrons. So 21 plus 5 gives me 26. 26 divided by 2 gives me 13. And so I have nitrogen, bromine, bromine. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I have 13. Okay. So I have a electronegativity difference between the bromines. This is going to be negative, and this is going to be positive. Okay. Do we see any symmetry? Do we see symmetry, guys? Who knows? This is a bit of a difficult one. There's no symmetry. Okay, nice. Do we see a difference in electronegativity between bromine and nitrogen? And let me redraw this so it's more clear, guys. This is how it would look like. This is not symmetrical, right? There's an overall lone pair negative charge, and there's bromine coming from all directions. So this would have, this would actually be polar. We just have to double check if it's the most polar. So now we're going to compare it with ammonia. And we're actually going to find out that ammonia looks similar. Ammonia looks the same once we draw it out, if I remember correctly. It looks something like this. But since the nitrogen to hydrogen electronegativity is much greater than nitrogen to bromine, notice how they gave you both nitrogen as a reference value. You have to pick your answer based on this. And that's why D is the correct answer. Does that make sense, guys? Someone's asking, can you just calculate the electronegativity difference? You can, but to cancel A and B, you have to cancel out the fact that it's symmetrical. Wait, why D? Because the electronegativity difference of nitrogen and hydrogen is larger than nitrogen and bromine. That's why it's most polar. The question is asking which is most polar. Would the electron geometry be trigonal pyramidal? So the electron domain geometry for this one, you mean? This one would be tetrahedral. Can we see it with the difference in calc between C and D? We can. Does anyone have the electronegativity values? C is weaker. Exactly. Good job. So exactly. So the molecular geometry would be trigonal pyramidal, but the electron domain geometry would be tetrahedral. Okay? Nice. Perfect. Let's have a look at the next one. This is, once again, just a repeat question, a fire question to get. I would love this question on my exam. It says, which allotropes of carbon are electrical conductors? And I'll give you guys a memory trick. I'm going to see if you guys get this. Okay? I think there's like discussion about the electronegativity difference. I'm going to calculate it and I'll get back to you guys. Is it B? Okay. So we have graphite, diamond, and graphene. Anyone have any other idea? We have some B's in the chat. Thank you guys, by the way, so much for 15K likes. I really appreciate y'all. Thanks for showing the live some love. B. Okay, you guys are doing so well. Does diamond conduct electricity? So in my head, I'm already thinking, does diamond conduct electricity, guys? No, right? Diamond does not conduct electricity. And this is how exactly how I would answer in my exam. I know diamond does not conduct electricity. I can confidently say that. So I'm going to cross out 2. Without even processing what's next, I'm going to cross out A. I'm going to cross out C. I'm going to cross out D, circle my answers B, and move on. Does that make sense? I can't explain why. I will explain why, but I'm just showing you like the exam techniques that you should be applying. So once you find that something's confidently wrong or confidently correct, you technically don't even have to read the other ones. And that's how you can answer things very fast and then give yourself a second chance to then re-look at your answers, because ideally what I really recommend for students is to do the past paper once, your exam paper once, and then have a look at it again. Okay? And so this type of technique is a really good example of how you can apply this technique for these types of questions where it's like pick one of the options, because it will be very helpful for you. What past paper is this? This is time zone 3, November 25, SL, paper 1A. Okay, so now let's actually explain this question. Let's actually understand it. So we know graphite. Graphite is essentially, well, actually, let's explain what graphene is. So I always teach my crash course students, graphene ends with E and E, and E and E looks like 1. And so graphene is one layer of trigonal planar, hexagonally shaped carbon bonds. This is a horrible drawing. I'm so sorry, guys. But essentially it looks roughly something like this. And so it's one layer of hexagonally shaped, okay? Graphite, multiple. So remember, graphite has a T, multiple has T. It's multiple of those layers. And so because it forms layers, essentially what happens is it has layers like this. And in between those layers, there's something called delocalized electrons. And these delocalized electrons are what allow it to conduct electricity. It's just something you have to memorize. The graphite has electrical conductivity. Graphite, of course, has electrical conductivity because it's multiple layers of graphene. And then diamond does not. The reason why diamond does not is because diamond is actually a tetrahedral structure. You do need to know this. And it forms a tetrahedral structure with no delocalized electrons. So what is the exam tip I'm going to tell you? Whenever you see in IB chemistry electrical conductivity, what are you thinking of? You're thinking of delocalized electrons immediately. Delocalized electrons. If something has delocalized electrons, it will conduct electricity. Okay? You're thinking of delocalized electrons and acids and bases. This is where you're going to see electrical conductivity. And of course, redox reactions. Okay? So delocalized electrons, acids and bases in redox is going to be connected to the electroconductors. Where are you going to see delocalized electrons? You're going to see in allotropes of carbon, graphites, graphene. You're going to see um, for HL higher levels. You're going to see it in resonance structures. And those are the most common ways you're going to see this electrical conductivity in past papers. So keep that in mind. Okay? Hopefully that made sense, guys. Okay? Thank you guys so much for 16K likes. This one says, which one has the strongest metallic bond? Again, repeat question. If you've been doing past papers, this is an easy one to answer. What are we thinking in the chat? Someone's asking if we're doing a paper 2 too. So we're going to try to do as much of this past paper as we can. And then if you guys want tomorrow, I can do a paper 2. Or I can do math tomorrow. What do you guys prefer? Or I think actually maybe Minna, the other crash course tutor, will go live tomorrow. I'm not sure. Nice. So someone said smaller radius. Okay. Anyone have any other idea? Nice. Look at the periodic table based on that. Exactly. It's just as simple as that. And so we know that what's a metallic bond? Who knows? Who can do some active recall? There's a specific word that you have to say when you're talking about metallic bond, and that's the electrostatic attraction. Actually, these two statements, electrostatic attraction, has to be said in all the types of bonding. So whether it's covalent, electrostatic attraction between a cation and anion, or metallic, electrostatic attraction between what? Very good. Cations, which is the metal like magnesium 2 plus, this is your cation, a positive ion, and delocalized electrons. Now, once again, guys, to get that mark in paper 2, you have to say electrostatic attraction when you're talking about bonding. So keep that in mind. Okay, so if it's the electrostatic attraction between a positive metal and delocalized electrons, and essentially, careful, it doesn't form a lattice structure. A lattice is with ionic bonding, by the way, because you wouldn't get the mark for that. Careful. So essentially, what it forms is it just forms layers of metal, 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 and delocalized electrons. So metal, 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 and delocalized electrons like this. Okay, and so basically, the strength of a metallic bond depends on how close the electron can get towards the center. And that all depends on the radius, just like someone correctly said in the chat. So all you have to do is just look at which one has the smaller radius. And if we look at the periodic table, who knows which one has the smallest radius, guys? Magnesium, aluminium, potassium. Okay, it's definitely not potassium because that's in period 4. It's definitely not this one because it's in period 4 as well. Because you know, down as you go down the groups, the radius increases. And then you have Mg2 plus and Al3 plus. Which one has a smaller radius, guys? I'm gonna not answer this one. I'm gonna wait for you guys to answer this one because I revised all of the chem the past few days, but I can't answer shit. I'm so cooked. Ooh, how did you revise? Maybe it's the way you revised it. Very good. Damn, Leia's eating it up. Higher charge. Exactly. You're looking at the ones at the higher charge. So actually, let me tell you a foolproof method, and then let me tell you about the higher charge thing, because she is right, and that's for quick answers. So the foolproof method is just to count exactly how many protons and electrons. So I believe from memory, magnesium has 12 protons, and aluminium has 13 protons. Sorry guys if that's wrong, but from memory. And we know that if something has 12 protons and it's a 2 plus charge, it means it has 10 electrons. And if something has 13 protons and it has 3 plus charge, it means it has 10 electrons. So if this has 12 protons and 10 electrons, and this has 13 protons and 10 electrons, which one's going to be smaller? The one that has more protons, right? The one that has a higher charge of plus in the center, because it's able to attract more the electrons. So actually my answer is going to be Al. Now Leia correctly said the higher charge. This is exactly just how you can do it quickly in your exam. So if something is in the same period, all you have to look at which one has the higher charge, which one loses more electrons. Because the one that loses more electrons is going to have a higher proton to electron difference, and therefore you can just look at which one will have a higher charge, circle, and move on. Okay? Just went over notes and revision dojo question papers. Ooh, okay. So, um, I really recommend that you don't go over notes, and it's kind of bad, like as a person who works for 87 telling you this, but my advice for genuinely biochemistry is to watch videos as much as you can. I really recommend our crash courses. We teach you the whole syllabus in 5 days. It's kind of like hard recommending this because I like work for EC7, so it's not true advice. But I want to tell you why I recommend it. The reason I recommend the crash course is because it's taught by what me I'm one of the tutors. It's taught by tutors who go over the syllabus from start to finish, and they know the syllabus and the past papers that are coming up. So you're being taught on video exactly all the types of questions you need to know, how to solve every single type of questions, which which terminology you need to say in your mark scheme specifically, which steps you need to do in your mark scheme specifically, because we are just so adapted to IB. So I'd really recommend that you either try to find some sort of video source that you can just cram learning the content quickly, not look at your notes. Do not look at your notes. This is in no way helpful at all. And yeah, like I just really recommend our crash courses. I was a crash course student before I became a crash course tutor. And I can say, like, hand on heart, wallahi, if you know what wallahi means, you know what that means. I would have not been able to get a 7 in chemistry without it. Can you do a paper 1B next time or tomorrow? Sure, I can. All right, I'm sold. Okay, I'm glad that you're sold, but I like it's about like so. What methodology you should do is you should sit down, watch the video of the crash course, okay, and after you watch the video of the crash course, let's say you watch topic one, you go straight to the topic one questions, okay, and then you do topic one questions, then you watch topic two video, okay, and then you do topic two questions, then you topic three video, and you do topic three questions, and you need to do that ASAP, ASAP, bro, because exams are soon. And once you do that ASAP, then you just do past paper, past paper. You should not be looking at notes. I mean, you can be looking at notes, but you should not be recreating your notes. Like something that you should have notes already pre-created, whether that's the crash course notes or your own notes, but that's something that you should be looking at as you're doing questions, not something that you're like dedicating time, like, okay, let me look at my notes, read my notes, and stuff like that. So if you're doing, let's say, an acids basis question and you're stuck on this acids basis question, you're like, I don't know how to do this. You can look at your notes to help you. But the main method of studying is me doing the acids basis question. Does that make sense, guys? Without the what, you were lagging. I was saying without the crash course, wallahi, I wouldn't have been able to get a 7. I pulled out the wallahi, guys. That's crazy. Okay, let's go ahead and move on to the next one. I was kind of like yapping about the crash course. Any advice for a way to study bio and chem as HL? I don't know if the way I'm studying actually works. Okay, so once you do the crash course, or once you, whatever, cram the whole syllabus in whatever way you want to do it, whether that's crash course or whatever, you're gonna do this. You're gonna do topic video, topic questions. Topic video, topic questions. Stoichiometry video, stoichiometry questions. Periodicity video, periodicity questions. Then once you've covered all the syllabus, you just do past paper, past paper. And when I tell you do past paper, I don't want you to just do a past paper and be like, oh shit, I got a 5. Next past paper. Oh shit, I got a 4. Past paper. No, you're gonna sit down, do this past paper. Then you're gonna pull out the mark scheme next to you, and you're gonna see which ones you got wrong. And I want you to act as if you're stupid. Be like, I got this question wrong. I'm being so for real, guys. I'm being so for real. I got this question wrong because I forgot that as radius increases, metallic strength decreases. And you write that down. Then you take a screenshot of what you got wrong and you keep a folder in your phone of all the ones you got wrong. I literally had a folder chemistry wrong, bio wrong in my notes. And then at the end of the day, after you've done doing these questions, these past papers, you look at all the ones and you read the statements. I got this wrong because I got the radius wrong. I got this wrong because I messed up. I forgot to multiply by 2. I got this wrong. This is going to be the best way for you to adapt to the IB questions, to be familiar with the IB questions, predict you yourself. Guys, do not fall for any prediction papers. Do not purchase any prediction papers. They are not going to help you. You need to sit down and do past papers. Like, genuinely, nothing will help you if it's not a past paper. Okay, there's so many past papers. If I can't do the crash course, how do I study for bio and chem? For bio, 100% you should do, then download the syllabus guide. Download the syllabus guide. Go through every single point yourself and try to learn from the syllabus guide in unison with some sort of visual stimulus, and try to do that as fast as you can. Okay? Flashcards for bio work for bro. Flashcards for bio, 100% recommend. 1000%. Flashcards are a really good way to do active recall. Bio whiteboard. In between past papers, let's say you do a past paper question and you keep getting respiration wrong, and you're like, how do I keep forgetting respiration? I've done this so many times. You sit down, you pull out your whiteboard, you pull out your iPad, you pull out a blank page, and you literally sit down and you do respiration. You say it 3 times out loud. You write it 3 times out loud. You draw it 3 times out loud. You give yourself a 30-minute break. You come back until you can do it from memory. And this types of like active recall or memory help in unison with doing questions is going to be the best way forward. I'm kind of like giving advice all over the place because I'm just a bit overstimulated right now, but I hope what I'm saying is helpful. Yes, blurt method, exactly. That's the method I still use now um for like medical school exams. Do you have any advice how to do database question bio? Okay, Anna, very good question. This is like a heavy loaded question. Um, do I have any advice? So database questions for bio specifically, and I'm going to tell you the pattern for bio. For bio, guys, this is what IB does. IB will tell you, like, for example, let's say you your whole life knew that the sky is blue. I'm being so for real right now. I'm being dead ass. You your whole life, you know the sky was blue. In IB data bio question, you know what they do? They literally will give you data saying the sky is purple. And it's gonna be like sneakily. It's gonna say like the sky is purple sneakily in like a really weird graph with a bunch of like diagrams and a bunch of like weird things, and you're gonna be looking at it like this. What is going on? And then they're gonna ask you to make a conclusion about the color of the sky. And this is where students make mistakes. They make a conclusion based on the content that they've learned throughout bio, that the content that they've been fed, which they assume is correct in bio, like mitochondria is the powerhouse of the cell, the chloroplast is for photosynthesis, and they don't make direct conclusions from exactly the data. Okay? And this is where 90% of the students fail in database questions. You need to only look at the information in the data and make conclusions based on the data, especially because IB will purposely give data that gives contradicting information to what you usually generally think. Okay? And hopefully that helped you. I think if we do a database question together, a database past paper together, I'm gonna highlight this more in application because it's a bit hard showing it with this sky is blue example. But this is basically IB, how they do paper one Bs. Okay? Did that make sense, Anna? Please let me know if that was a bit helpful. But basically, just try to only read the information in the question and make conclusions based on the what the question is telling you. Like pretend you don't know anything about bio when you're doing a database question. Okay. Um, if not crash course, then revision village vids. Okay, so I honestly have different opinions on revision village. I used to use my friend's account when I did revision village, and I used it for math AAHL. And honestly, I would not recommend it only because, guys, because I think some of the questions were too hard in Revision Village. And I remember doing their prediction papers for M23, which when I took my exam, and it was so insanely hard, and it really overwhelmed me. And I did the prediction paper for my year, and it was not accurate, and I was really disappointed in that. But low key, who am I to complain? Because I was just using my friend's account, like I didn't even buy it myself. But otherwise, I think Revision Villages was really good for me when I was studying for a test. Like when I was doing, let's say calculus test, I would like study from Revision Village topical calculus questions, and then I would get a good score on my test. Okay, but not for IB exams for math. Okay, thank you so much. Okay, I'm glad. Someone's asking about. Do you recommend the predictive papers for Vision Dojo? I don't recommend predictive papers. Period. Do not fall for that shit, y'all. That's like a marketing, not a marketing tactic, but like some sort of like um ploy to be like, oh, it's gonna prediction papers are not real, bro. You cannot predict unless you've done this. Yourself have like also just because I know that prediction papers are by revision those are created by AI, and I don't think those are accurate. Okay, but for chem or bio, what vids do you recommend? So someone recommends. I know lots of students recommend Cyrus Revision, and for chemistry, I really recommend MSJ Chem. Yeah, someone also said in the comments Cyrus Revision. The one thing with Cyrus Revision is they don't cover every single syllabus point, so you yourself have to go make sure that every single point in the syllabus is covered. Another thing I recommend is our crash courses. We cover every single syllabus point. MSJ Chem, bro, MSJ Chem. He runs my diploma. Him and the crash course tutor Minna, they I owe them my diploma. But MSG Chem, I didn't use to study for my final exam. Once again, it was kind of like I used it like revision village to study for like topics. You know what I mean? Like periodicity test. I would use MSG Chem. I think it's also, guys, to tell you something kind of heartbreaking. The way you study for your IB exam is going to be so different to how you've been studying for topical exam tests and like yeah, how you've been studying throughout the 2 years of IB. And actually, when you come to that realization, sometimes for students is way too slow that they come to this realization and then they're fucked. So you got to be careful that you differentiate those two things. Like the way I was studying for tests is not how I'm studying for exams. So I can recommend you resources, and all the resources you're saying are good for studying for a test. For your exam, I really recommend the crash. You cover every single syllabus point in video. You need to find something like that. So if you can't do the exam, then you need to pull out the syllabus checklist, the syllabus guides, and you need to go through the syllabus guides. And it's going to be different to how you're studying generally for like a test, an IB test. Okay, does that make sense? So I just looked at the crash course and all the dates for the online meetings are in March. Yeah, so the crash courses, the live crash course is already over, but all the recordings are up. Let me show you actually, if you guys want. Do you want me to show you or do you want me to do the continue past paper? Teaching me bio is so long. Yeah, that's the thing, guys. Lots of resources are really, really good. The issue is that they're only helpful for like tests. And it's just really like you can show us. Okay, let me show you quickly, guys. Um yeah, lots of resources are good, but they're good only for tests, and it's like you need to like actually come to terms or come to the realization that to study for a 2 year syllabus, it's gonna be deadly, bro. Like you need to do a whole different approach. Oh hell no. Why not let me share, bro? Hello? Bear with me now, bear with me. Bear with me. Alright, there she is. Can you see my screen, guys? Hopefully? Okay. So this is how the vibes are. This is how the vibes are for the crash course. And I'm gonna oh, okay, so I'm not gonna only show you the crash course, I'm gonna tell you what you should do if you do end up buying or like okay, or pretend like or I'm gonna tell you how I would study. Okay, I'm gonna pretend I'm studying. So I pull up to the crash course like this, and then I go to should we do chemistry? Yeah, let's do chemistry. And so I pull up to moles topic, and I'm ready to start. So I'm gonna do topic one moles.
Okay, so
Okay, this is what you should be doing. So here's my topic one moles. Now you go to the resources and you can download the slides. What I like doing is I like pulling up the slides on my iPad and annotating the slides as the tutor is annotating the slide because I like copying exactly what the tutor is doing. And this is my favorite shit, guys. Look, 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 look. I pull up like this and I put the 2 times speed.
so we're gonna
And I'm
start off with
watching her on 2 times
models of
speed. And I'm
matter,
like,
then we're gonna go through the nuclear atom, and then the teacher's gonna take over for the moles.
okay.
So
And so then I like having the slides. Some students like having something called the resource pack. So this is what the resource pack look like. So the resource pack is essentially the slides, but they're empty, the slides, and it has the syllabus checklist. So as the tutor is like explaining, you like check things off, okay? But also the slides also have the syllabus checklist, so whatever you want. And the resource pack is essentially the slides, but they're empty. So I can show you now. Like for example, the first thing that we teach in the syllabus is models of particulate nature of matter, and you'll see that this is what she
so
goes,
this is really,
and
really
this is what
simple.
she
Those are pure
explains.
stuff. They're not mixed with state. So
Okay.
yeah, etc.
And she's explaining
Oxygen,
it, yada, 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 homogeneous,
physics,
heterogeneous.
individual properties, whatever it is that's
And
holding
she's
them together.
filling in the
So because compounds are
blanks,
chemically bonded
and
together,
you can
very
just
well
fill in
held
the
together,
blanks in the
they
resource
cannot
pack.
be
Personally, I
bicovalent
don't
bonds,
like
bionic bonds. They
so
cannot be
much the
separated
resource
by
pack.
physical
I
techniques.
like
So physical techniques usually involves heating, filtration, or
the
co-fusing together
annotating
today.
slides.
But those are the ones that can
Whatever.
separate mixtures, not
So then you
compounds. So make
watch
sure
the
you
video,
understand
and
the
you'll
number of
notice that in the video,
think about
she doesn't just do questions. She does also does IB questions with you.
state,
Like she
pure
doesn't only do content.
hydrogen.
So you're technically also doing questions already. Then you go to, of course, the syllabus checklist. Then you go to do topical practice questions. So once I finish watching the video, I'm gonna pull up here and I go to day one resources, and then I do practice questions. And then watch this, guys. I've created these questions for you. These are all the state changes questions that have shown up. If you were here from the beginning, you knew that this question showed up. First question, N25, was what was the sublimation? It was something like the sublimation question. Look at this. All the questions on state changes, all the questions on mixtures, all the questions on nuclear notation, all the questions on isotopes, all the questions on this. So as soon as I've watched that video, I'm gonna do topic practice questions. Then I'm gonna move on to the next video. Okay? Yada 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 yada. And then once I've watched all the videos, I go straight to past papers and I just do past papers. I get a question wrong. I'm gonna highlight the fact that I got this question wrong in my past paper. I'm gonna go rewatch the content, see why I'm not understanding it. Is it a fault in memory? Is it because I can't remember? Is it something that I'm calculating wrong? Is it understand why you got this question wrong? If it's something that's wrong with memory, you need to go back, do some flashcards. You need to go back, do some like blurt method. You need to go back and memorize better. If it's something in calculation wrong, you watch the rewatch the tutor calculate with you. Now, of course, you also have additional resources. Like for example, guys, I don't recommend prediction papers, but what you can do is analyze the past papers. Past paper analysis are helpful. Okay, what is a past paper analysis? For example, for past paper analysis here, I've compiled every single M25 question that's about mixtures and I put it here in the question. Every single chromatography question that has showed up in M25, I've brought it here. Every single polyatomic question, I've brought it here. So you guys are able to, you yourself know which topics are common, which topics are repetitive, and they're all compiled in the document. Another thing that's really helpful is looking at, for example, these cheat sheets. So these cheat sheets are all handmade. And for example, if I look at PKA, PKB, this is deadly, by the way. This is HL question, PKB, PKA. And it tells you every single way a PKA, PKB question can show up on your exam and exactly how to solve it in the context. Okay. And so these notes are helpful because you don't have to, like, first of all, recreate your own notes. And it's application notes. It's not like me reading the book and learning from start to finish what PKA is, what PKB is, because you've already watched that video. You're applying these cheat sheets by learning how to solve every single KA, KB question, and so on and so on. Okay? For your exam, how did you practice paper 2 long answers in bio? Wow, fire question, Anna. This I'm gonna show you now. This is how I did it. First of all, the bio tutor, because when I did the crash course, she went over the long answer questions that I needed to know. And Loki, I kind of honestly, for long answer questions, I didn't study in a specific way except watching the crash course videos. But I also use this. Let me show you. Let me show you. I use this. I use this document. So this document is all the possible IB long answer questions and their mark schemes. And you just read them and you read the mark schemes and you try to memorize mark schemes and you try to highlight the keywords in mark schemes. I think that would be the best advice for paper 2 bio. Personally, for me, the crash course videos and Minna going over the long answer questions in the videos were enough for me. But it depends. Um, Okay. Wish I had found you sooner, not gonna lie. Yeah, I know lots of students are. I'm really like upset that some students couldn't join the live session, but I promise also the recordings are gonna be helpful. Okay, but how can I tell if my answers are correct? Do you got the answers ready? Yes, we do. Don't play, girl. Yeah, we do. So you'll see if we go back here. Don't play, girl. I got you, girl. I got you. Look, see if you go here, where is it? No, this is bio. Well, let me show you the bio practice questions because I also made this and I'm so proud of this. Look, for bio, I created different types of questions. So these are all the MCQs that has showed up on water. And then the mark scheme at the bottom. And then all the long answer questions that has shown up on water. And then all the carbs and lipids. So for example, this is what you should do. You watch the topic 2 video and then you cram this 63-page document of IB past papers. And then you're goaded. You're done with topic 2. And then you're just ready to do topic 3. And then you do topic 3. And you do questions for topic 3. You do topic 4, and you do questions topic 4. And then once you finish the whole syllabus, pass paper, pass paper. That's all you should be doing. Okay? Does that make sense, guys? Like how you would use that to learn. And so if you don't use the crash course to study, have the syllabus guide up, cover topic 1 practice questions, topic 2 syllabus guide, topic 2 practice questions. You know what I mean? So it doesn't necessarily have to be the crash course that you use. Maybe you can't buy the crash course. Oh, also let me show you a discount code, M2610. How long do you do the lives here? Kind of based on vibes. Today I have nothing to do, so it's based on vibes. We can continue doing the past paper if you guys are ready. We also have Anki flashcards to help you. We have a list of all the drawings for bio. We have whole syllabus notes, but these are old syllabus. The past paper analysis with the answers for bio. cheat sheets. Also, guys, I want to show you something. If you're not sold about the crash course because you're like, I don't know what this girl's talking about, we have a free demo that you can just abuse. It's a video of our tutor explaining respiration. Abuse that to your liking. You have a free cheat sheet that you can use. Abuse it to your liking. This is an example of a cheat sheet. This is all you need to know about respiration. I actually created this myself, and I'm so proud of it. And hopefully you guys like it. So abuse the free resources when you can. And this is a free like demo pack. And so you can watch this before you buy the crash course because maybe you want to like see the vibe first and apply it. And I beg, watch everything on 2 times speed, guys. My attention span is like so slow. This is my favorite feature. Okay, how long do you do lives? I think I answered that. Where can I find the mark schemes for all the topics? Because that's really genius. What do you mean? Mark schemes for which ones? Like the long answer, all the long answer questions, all the possible long answer questions. It's in the additional resource question subsection. When do you start the lives? Here is it scheduled. It's kind of not. I'm so sorry to say this because I'm not organized enough, and I got uni as well. So what I'll do is, can you turn on the notifications of the live? And what I do is, I'll post it on the bulletin. So if you go like here, if you go, let me show you. Let me show you. If you go to Easy7 account and you go here in the bio, it's like this chat that you join, and I generally just post here when I'm gonna go live, and then I do a poll of which topic I should do. So for example, I did a poll really quickly, and people voted chem, and that's why I did a chem past paper question. Sorry, past paper. The long answer one, you can just get that in the additional resource section on the crash course. Up. Do you guys want to see something else, or should we continue with the past paper? Oh, let me show you math. Is the chat free to join? Yes, yes, it's free. You don't gotta pay. Also, guys, in the chat, if you scroll up, there's this drive of all the annotated past papers that I do here. I'm gonna like share this and like export it and put it on the drive, and the drive is free. Don't worry. So join the bulletin and then go up, 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 up. You'll see like a drive link, and that has all the annotated past papers that I do during the live. Does that make sense? It's right here. Anyway, so yeah, let's continue with the past paper. I'm out of breath. Okay, which element is a p block element? What are we thinking? Oh my god, we hit 23K likes. That's crazy. Which past paper is this? This is Time Zone 3, N25, SL Chemistry, paper 1A. Okay, let's have a look. So what is P block? Well, we know we have an S block. We know we have a P block, which is like the side thing here, and then we have a D block element. So I just have to look at my periodic table. Let's have a look. So I'm opening my periodic table here. I see that SN is SN. Where's SN? Damn, where is SN? SN is a P block element. So it's actually, oh no, this is a D block, sorry. SN is somewhere here. Okay, so answer could be A. TE is also here. Okay. And then you have CD, which is a transition metal. This is definitely transition metal, not here. And then you have AT. Let's have a look where AT is in the periodic table. AT is also, where is it? AT is also here in the P block. Okay. Then it says, which element is a P block metal? Now, what is a metal, guys? Who knows? It's a metal. We know the P block is made up of what? It's made up of metalloids. There's that section of that, that section like this. I don't know if you guys seen a recent periodic table, but if you pull up periodic table, you'll see that there's a section that is metals, metalloids, and then non-metals. So the only one that is part of the non-metals is A, which is SN. So this is a non-metal, and this is a non-metal. That's why the answer is A. Does that make sense, guys? Yeah, it's metal. That's why the question seems a bit confusing, but this confused me because aren't both TE and SN P block? Yes, they are, but they're non-metals. Okay, what was the answer for 10? Uh-oh, I didn't do 10. Thanks for reminding me. This is which type of material is a good conductor of heat and electricity in a solid and liquid state and is insoluble in water and typically has high melting point. Oh, okay. So, electric electrical conductivity. Do guys some review if you want in the chat. If not, if you're tired, it is quite late actually. It's 10 o'clock. You don't have to do some active recall. But what did we mention? Electrical conductivity generally happens in acids and bases, in redox, in metals, when you have delocalized electrons in resonance. Okay. Now it's electrical conductivity in solid and liquid. We know that ionic compounds do not conduct electricity in solid. They only conduct it when it's aqueous. So it's definitely not ionic. Metallic do in both, okay? So it could be metallic. Insoluble in water, yes, metals are insoluble in water. High melting point, yes, metals have a high melting point. So actually my answer here would be D. Are we happy with this, guys? Hopefully, yes. Thank you guys so much for the 24K likes. All right, let's move on because there's no objections in the chat. Which two elements form a compound with the strongest ionic attraction? Wow. So we have strong metallic bonding, we have strong ionic attraction, common. This is also a repeat question. If you've been spamming past papers, you know this is a nice one to show up on the exam. Nothing new, syllabus. So we're good to go. Anyone have any idea? So strongest ionic attraction. How do we deem if something has a strong ionic attraction? It has to do with what? The radius and the charge. Once again, it's kind of similar to the metals, right? Yes, no, maybe so. So I'm looking at something that has a smaller radius and something that has a higher charge. And it's the same exact conceptual thinking as we've been talking about metallic bonds. So ionic bonding, we know, forms a lattice structure. How does a lattice structure work? Well, the lattice structure, let's just do NaCl because this is the easiest ionic compound to think about. NaCl forms a lattice structure, meaning for every single sodium central cation, I have the chlorine anions in six ways, six surrounding ways, like this. Okay? And so the attraction between the chlorine and the sodium is dependent on how small that radius is of sodium, how small the radius of chlorine. Because the smaller the radius, they're able to have stronger, closer attractions. So I have to find out which one, lithium or potassium, has a smaller radius. Very good, exactly, high charge, small radius. So I look at my periodic table. I'm going to pull up my periodic table here now. And I see that lithium has a smaller radius. Why? Because it's higher up in the group 1. And so my answer is definitely not going to be C and D. Now you have 50% chance of guessing. But it's quite simple. Which one has a smaller radius, oxygen or Se? Clearly it's going to be oxygen, I think. Yeah, it's going to be oxygen because there's oxygens higher up. So my answer is A. Are we happy with this, guys? Quick, easy question. I don't think this is too bad. Which oxide is the most basic? Again, a repeat question. Wow, this is a lovely past paper. If you've been doing IB past papers, then you would have already seen most of these questions before. Guys, IB is so repetitive. Please do past papers. Remember, center your studying around past papers once you finish learning the content. That was the whole study approach I'm telling you, okay? So this is a repeat question. Which one is the most basic? What is this? This is part of the periodicity units where you're supposed to learn that metals form basic oxides, non-metals form acidic oxides, and then you have, for example, aluminium. And aluminium is a special case because it's amphoteric, which means it's both basic and acidic, right? And so the ones that's going to be most basic is going to be a metal. Which one's a metal? Magnesium. That's why my answer is A. Are we happy with this, guys? Please let me know if I'm going too fast as well. I'm more than happy to slow down, but I'm sensing that these questions are quite easy. Yep. Okay, perfect. Which compound has the highest boiling point? Ooh, common question. Once again, a repeat question. This is not new syllabus. This has been old syllabus. If you've been cramming past papers, you've seen a question like this before. Now, this has to do with the concept of like alkane branching. This is good speed. Okay, perfect. Alkanes branching versus non-branched. And this is a really, really important concept that is constantly asked in biology and sometimes asked, as we see here, in chemistry. If something is linear, guys, like this, so long carbon to carbon to carbon to carbon chains, versus something that is branched, does anyone know which one's easier to break? The linear structure or the branch structure? Who knows? Please, I want you to answer this in the chat. Try guessing. And if you get this right, pat yourself on the back. Very good job. Branched is the one that's easier to break. Exactly, very good. The branched is easier to break. The reason for that is all has to do with surface area. Nice, exactly. So in my branch structure, I have a higher surface area, okay? And so I can approach this molecule from multiple different ways, okay? And therefore it's much easier for me to break branched in comparison to linear, which has a smaller surface area and therefore is much harder to break. So which one has a higher boiling point? I'm already looking for something that is linear, something that is not branched. And so off the top of my head, I'm thinking already of canceling C out. Is everyone happy with how I canceled C to get it out of the way? Okay, I'm thinking of what exactly is the longest chain, longest linear chain. And I can see A is linear, correct, but it's not as long as B. B is the longest linear change of carbon to carbon to carbon chains. Once again, here it's a long chain, but it's branched, and so it has a lower boiling point. Does that make sense, guys? Also, keep in mind that if something has more carbon to carbon to carbon chains, you can say that it has higher London dispersion forces. Are we familiar with this? And therefore requires more energy to break because London dispersion forces are all dependent on the weight, the molecular weight. Okay? I'm going to move on. Please let me know if that didn't make sense or if you want me to repeat. Thank you so much for the rose peach. I don't know if you sent that now. Oh no, that was before. And thank you guys for the 25k likes. Okay, let's have a look at this one. What is the sum of the coefficients when 1 mole of propanol undergoes complete combustion? Once again, guys, this is a question that would have generally showed up in the beginning of your past paper in the old syllabus, but now it's just towards the end. And what is the sum of the coefficients? You just have to balance it out. Wouldn't branched also have London dispersion forces? What is the difference here? Good question. So, branched would have LDF forces. And so, essentially, you're right, branch would have LDF forces. The difference here between a linear and a branch structure is that a linear would have a higher boiling point because it has a lower surface area and therefore it's harder to break. Does that make sense, or do you want me to break that down um, in simpler? Because I realize that I am just like saying the IB final terminology, but not explaining conceptually what that is. Let me know. I can explain that better. Okay, we have a C in the chat. So sum of coefficients makes sense. Okay, perfect. So that would be the difference. I'm glad. I'm glad it makes sense. So for 15, there's already like the sum of the coefficients of 1 mole of propanol. Okay, so 1 mole of propanol undergoes complete combustion. So they're telling me basically if it's 1 mole, the coefficient of propanol has to be 1. And if the coefficient of propanol has to be 1, what is the amount of carbon dioxide and water I form? So always the technique I tell my students is to write out the elements on the right and left hand side. Here I have 3 carbons, here I have 8 hydrogens, and here I have 3 oxygens. Here I have 1 carbon, here I have 3, oh no, sorry, not 3. I'm getting tired. 2 hydrogens, and I have 3 oxygens. And I have to balance that out. How do I balance that out? I'm gonna put a 3 over here because I want to make this 1 turn into a times 3. Once I make it a 3, what ends up happening is I also make my oxygen become 7. Okay. And then I have 7 oxygens. I have how many hydrogens? Let's see if I can balance out the hydrogens. I'm going to balance out the hydrogens by putting a 4 here. That creates this an 8. And then I have 6 plus 4 gives me 12. Let me know if I'm going too fast or anything, guys. I'm happy to slow down. And then I can put here a, let's see, 11.5. Here I can put a 5. No, 5.5. A 5.5 to balance it out. And this will give me a total of 12 here, a total of 8 hydrogens, 3 carbons, 3, 8, 12. Okay, so this is what I get when I balance it out. Let me know if you want me to break it down a bit simpler because I know I just kind of went in my head there. And then to add it all up, it would be 6.5 plus 3 plus 4. That would give me 10.5 plus 3. And that gives me 13.5. See, I've done something wrong. Let's see what I've done wrong. I'm sure it has to do with the oxygen. What's 11 divided by 2? That's 12. Carbon's 3. Hydrogen's this. What silly mistake have I made? Does anyone see my silly mistake? I think it's because I don't take into account the 1 mole. I think I think the answer would be C as 12.5 because I don't take into account 7 hydrogens. Where did I make that? No, there should be 8 hydrogens. 4.5 for oxygen. Let's see. Okay, so if it's 4.5, that gives me 9. 9 plus 1 gives me that wouldn't work either. I don't think. Wait, let me break it down. So 3 times 2 gives me 6 oxygens here. You're right. You're right, Zoja. Exactly. Thank you so much, Zoja. You're completely right. Okay, so this is the silly mistake I made. Let me break it down for you guys. So 3 times 2 gives me 6 oxygens from my carbon dioxide. 6 plus 4 oxygen gives me 10. Okay, and so this actually would have to be 4.5 in order for me to get also 10 on this side. Thank you so much for helping me. Okay, perfect. So then my answer would be 12. Are we happy with this, guys? So I hate these balancing equation questions. Also, I would really recommend that you skip the balancing equation questions and come back to them if you're stressed, because I always skip them in my exam. I'm just gonna wait for confirmation that this is okay, and once this is okay, I can move on. I'm happy to redo it again. Yes? Okay, perfect. Let's go ahead and move on. Nice. It says consider these equations. What is the value of delta H in kilojoule per mole for this reaction? I love these questions because it's kind of like an escape room puzzle. You guys are doing so well. We're gonna try to maybe get to question 20 and end the live. So keep it up, and if we go faster, hopefully we'll get to question 30. Um, but we've been going live for like about an hour and a half now. It's okay. Okay, perfect. I'm glad, guys. So for these ones, simply you just have to essentially find the commonalities between the two equations and your main equation, and then you have to flip or multiply by the coefficients. So here I'm gonna first identify my sulfur, and I see my sulfur here, and I see that it's both in my reactants and in my reactants, in my first equation and in my final equation. So I don't need to flip my x value. I don't need to flip the sign of my x value. So it can just be x. Let's have a look at the next thing. The next thing I see in my second equation, I see that I have SO3 and I have SO3. They're both in my product side, so I don't need to flip the sign of my y. But what do I need to do, guys? I need to multiply by what? By 2, right? I need to multiply my y by 2. So it's 2y. Are we good to go? Does that make sense? Let's see if that cancels out my exponent. I see something wrong. I see something wrong. This is actually a more difficult question in practice. The reason for that is because once you essentially isn't that division? Um you're so right. You're so right. You're so right. You do have to divide. You do have to divide by 2. The reason for that is because I have 2 here and I need to get to 1. And so I need to take y and divide it by 2 in order for me to get 1 mole of SO3. Completely correct. And so therefore I have x plus y divided by 2. And therefore your answer would be what, guys? B, C, D, or A? Should be B, right? Wait, why multiply by 2? Why can't divide by 2? It is divide by 2. Sorry, guys, I made a mistake. It is divide by 2 because here it's 2 and then you go to 1. So it's divide by 2. I conceptually thought of it the other way where I go from 1 to 2. But you are completely correct. Exactly, very good. B is the correct answer. Perfect. Which statement is a disadvantage of using biofuels instead of fossil fuels? This is new syllabus. This is part of the energetics unit. They have not asked this in paper 1A yet. This is the first time they've asked this in paper 1A. This is a deadly question. It's not too deadly because we've covered this in the crash course. We went through a whole disadvantages of biofuels and fossil fuels, and we've covered it at the end of the energetics topic after enthalpy and delta G and all that stuff. And it's asking for a disadvantage of using biofuels. So, what is biofuels? Anyone know what biofuels is? You do need to know what biofuels are for your exam. We have an A in the chat. Okay. Land is used that could be used to grow food. Combustion releases more energy per mole of fuel. Emissions of CO2 to the atmosphere are lower overall. Crop waste can be used as fuel. So biofuels are essentially cheating because I have the slides from the crash course now. Oops. Low key, cheat all you want. Um, biofuels are essentially are more energetically, no, not energetically favorable, environmentally favorable type of fuels. Okay, because fossil fuels, their issue is that they release lots of energy and they release lots of combustion, but they're bad for the environment, and that's what you have to know. And so we have this introduction of biofuels, and you need to know what the biofuels are, examples of biofuels, and essentially how it's like essentially planting plants and like decomposing them and use the energy from the decomposition. And you have to know the advantages and disadvantages. And one of the disadvantages is actually you to in order to have biofuels, you need to grow the plants in order for you to combust them. And so land is used that could be used to grow food. It's basically a big waste of land. And actually, you have to like cut down land and deforest land in order for you to create space to grow the biofuels and then burn them. And that's why A is the correct answer. Combustion releases more energy per mole of fuel. That is true, but that's not a disadvantage of biofuels. Emissions of CO2 are lower overall. That's an advantage of biofuels. Crop waste can be used as fuel. That is an advantage of biofuels, not a disadvantage. Okay. Okay. Do biofuels compete with food production? Yes, that's kind of the key idea here. It's not necessarily compete, but it's like it's more of the concept of should we use this land to make food or should we use it to for energy? Because a lot of issues now we have is that we don't have enough land, and so the people are starting to deforest, cut down trees in order to make land just so we can plant food to eat. Okay, and so if we're competing now with planting whether we should plant food to eat or biofuels, now we don't even have more land. And that's kind of the main disadvantage of biofuels. What is the theoretical yield in grams of ethanamide that can be produced from the reaction of 4 grams of ammonium carbonate with excess ethanoic acid? So, whoa, that's a lot. I didn't even process what I read. Theoretical yield. Okay, theoretical yield that can be produced the reaction of 4 grams. Okay, so 4 grams of this one here, ammonium carbonate with excess ethanoic acid. Okay, so this is telling me this is excess. I'm just going to write excess. And I want the theoretical yield of this. Okay. Of what? Of this one here. Okay, the theoretical yield of. Okay, fire. So, what do I need to do? I need to essentially calculate how can I go from the 4 grams that I know of this ammonium carbonate and jump all the way to this one here. So if I have 4 grams of ammonium carbonate, I need to convert to moles because when I convert to moles, then I can apply the molar ratios and find out exactly how much moles I find out of this one. Okay, so let's go ahead and find that out. Um, okay, so if I have 4 grams of ammonium carbonate, I need to do the grams divided by the molar mass. That's the step one. The molar mass is 96.11. Okay, so I have 4 divided by 90. I'm just going to rewrite this because this looks horrible, guys. So sorry. 4 divided by 96.11. What does that give you guys? Oh, hell no. 0.0416. Hopefully you guys got the same. Okay, so that's how many moles I have of the ammonium carbonate. And then I have 2 times, I need 2 times that amount of moles. Why? Because I look at the molar ratio. 2 times that to create this one. Now, why am I focused on this one? I'm focused on this one because this is the common equation that's in both of my lines, okay? And so I need 2 times that amount. So I'm going to take 0.0416. That's going to be step 2. And I'm going to multiply that by 2 times 2. Oh, 416 times 2. And so the second step is going to be to apply that molar ratio and find exactly how much I make times 2. And that's going to give me 0.0832. And to have 0.0832, and that's going to be taken to create exactly C 1-to-1 ratio of my CO and whatever this, what is it called? Ethanamide. Okay? And so because you have a 1-to-1 ratio between the product here in red and the ethanamide, I can say that I have 0.0832 moles of the ethanamide. And so then how do I go from the moles of ethanamide? And I'm going to write ethan so you guys understand here. To the grams, I'm going to multiply by what? Who knows? Okay, we have a C in the chat. Nice. Who knows what I'm going to multiply by? I'm going to multiply by the molar mass. Very good. Exactly. Good job. So what's my molar mass? Here's my molar mass, 59.08. Let's see what that gives you. Oh. Okay, I got 4.915456, which roughly will be 4.92, and therefore my answer is C. Did everyone get the same? Are we happy with how I did this? Please let me know in the chat and I can move on. If not, I can re-explain. Yes, no, maybe so. Perfect. I'm so glad, guys. Let's go ahead and do the next question. Ooh, this looked deadly. I haven't looked at this yet. It says the volume of ethane as it reacts with hydrogen is shown in the following graph. Which graph shows the volume of hydrogen changes over time? What is this graph, bro? I've never seen this graph before in an IB exam. Okay, let's have a look at this. This is the volume of ethane reacts with hydrogen, fire. Which graph shows the volume of hydrogen changes over time? Okay, so basically, which shows the volume of your reactant hydrogen over time, and also CH2. Okay, okay, I get it. I get it. What are you guys thinking here? Oh my god, how did I miss this note? Is it gonna be on YouTube? Yes, I'll post it on YouTube. Don't worry. Also, you can follow our second account, guys. I created a second account. Loki, let me plug that. Let me plug my second account. I made a second account called Easy7 IB Science 2, where I just post the past paper recording. Can you guys go follow? Okay, someone said D, I think. Okay, so the key idea for this one, it kind of looks deadly, but it's actually not so bad. Oh, you already follow? Okay, that's so cute. Yay. Okay, yeah, don't worry. I'll post it on YouTube. Okay, the key idea is what I'm assuming that they want me to do is make a conclusion about the number of moles. Okay. And so I know, first of all, I know that my hydrogen is in my reactants, and therefore, is my volume going to stay constant? Do the volume of your reactants stay constant? No, it's going to have to decrease. Both of them have to decrease because it's in your reactants. Very good. Both decrease. Good job. Exactly. So my answer is not going to be B, it's not going to be A. I like that someone in the chat already said definitely not A or B. Very good technique that you're already seeing which ones you should cancel out. And it has to be C or D. Now, which one's going to be used up more? Which volume is going to be used up more? Is it going to be the hydrogen or the ethene? Can anyone guess by looking at the molar ratio? Which one's going to be used up more? Hydrogen. Very good job. Exactly. Therefore, my answer is going to be D. Okay? Because your ratio is 1 to 2. So for every single one of the C2H2, you're using 2 hydrogens for every single one of this one. So you're using double the amount of hydrogen, or just like more of it, and that's what this graph is kind of is showing. Does that make sense, guys, why the answer is D? This has never been asked like this before in an exam, and it's actually such a good question. And it's quite simple, but it has never shown up before like this on IB exams. So keep that in mind. Like it's like have it a warning, have it as a warning that they could potentially ask something like this moving forward. All right, which conditions would increase the rate of reaction between bromine and nitrogen oxide? Increasing temperature, increasing pressure, increasing volume. Now let's see. All right, hopefully this is a quick and easy one. I'm going to give you guys a couple seconds to think about it before I jump and answer it. But this is a common question, repeat question. You guys should know this. If not, you review your kinetics unit. We know something, and I've talked about this so many times in the crash course, so please, I hope you guys don't fall for this trick. Nice. Someone said in the chat the correct answer. What are we thinking? Anyone have any other idea? Does anyone know what the trick is? What's the trick, guys? So in the kinetics unit, you need to learn the effect of temperature, pressure, concentration, all of this. Increasing volume. Increasing volume is essentially has no effect on our rate of reaction. And so knowing that, you should always when you see increasing volume in your exam, cross it out. This is a red flag. They're trying to trick you. And 3 is incorrect, and therefore my answer has to be A. Okay? Increasing temperature, of course, increase the rate of reaction. Increasing pressure will, because we know increasing pressure is the same as um, essentially increasing concentration. Imagine a piston. Okay? So if I have This is me having low pressure. Okay, my particles in low pressure. Okay, in comparison to my particles in high pressure by pushing down and increasing the pressure. Now I have the same amount of particles. I have the same exact like moles, but I've squeezed them closer together, and therefore it increases the rate and has actually the similar effect as increasing concentration. That's why A is my correct answer. Very good job, guys. Okay, we've done past question 20. Do you guys want to spam do up until 30 really quickly before we end the live today? Or do you want to end it here because you guys are tired? Let me know. Once again, if you joined the E7 bulletin, spam it. Okay, let's spam it. But I'm a bit tired, guys, so bear with me now because we've been live for almost 2 hours now. But let's just spam it to get it done. And if you can be very interactive in the chat and answer quickly so we can do it quickly, I would greatly appreciate it. It says which statement about catalysts is correct? Catalysts increase the kinetic energy of reacting particles, affect endothermic reactions more than exothermic, increase reaction rates and are used up in a reaction, alter the mechanism of reaction. What are we thinking, guys, for 21? Guess if you don't know, we're gonna speed run the end of this past paper to make sure that you guys who missed it in the beginning. Anyone have any idea? Guess if it's wrong, it's okay. We have a D in the chat, okay. Anyone else? D? Okay. So they increase the kinetic energy of reactant particles? No. They don't increase the kinetic energy. They have no effect on energy, except what they have is that they provide an alternative pathway or alternative mechanism which has a lower activation energy. That's the proper definition that you need to know for your exam. A is incorrect. They affect endothermic and exothermic differently. No, misconception. They are used up in a reaction. No, we know catalysts are not used up in a reaction. D is correct. Why? Because by definition, the definition you need to say in your exam to get full marks is that catalysts provide an alternative pathway. They alter the mechanism of reaction by providing an alternative pathway with a lower activation energy. Catalysts themselves do not directly lower the activation energy. They provide an alternate pathway that has a lower activation energy. So make sure that you have that distinction correct, that we like stress the importance of when we're teaching chemistry, because that's how you're going to get the full marks. A crystal copper sulfate is in equilibrium with copper sulfate solution in a stopped flask at constant temperature. Which observation is possible? Now, if you guys know, and if you're a crash course student, you know, we've created a list of all the color changes that you need to know in your exam, and we've mentioned this one. Don't ever play. We've definitely mentioned this one, this copper sulfate. Many teachers don't teach this. This is something that you just know if you've covered the syllabus very well, and that's why we've created a list of literally all the color changes that you need to know. So do check out that document because it has this example of copper sulfate, and you have to know essentially that what happens to the color. Sorry, I don't know why I said color like that. So copper sulfate is in equilibrium with copper sulfate solution. So copper sulfate solid is in equilibrium with a copper sulfate solution. Solution meaning it's aqueous. The color of the solution becomes darker. The volume of the liquid decreases. The shape of the crystal changes slowly over time. The size of the crystal decreases. Now, does anyone know what answer you would give for this one? Thank you so much for the likes, by the way. I really appreciate 26K likes. You guys are the best. Anyone have any idea? So C is the correct answer. Very good job. Do you guys know why C is the correct answer? So the color of the solution becomes darker. So essentially what they're hinting at is that copper is a transition metal. And so copper, when it goes from bonding as a solid like this to becoming copper 2 plus, which is an ionic form of copper, it starts having color. And we know that the details of it is more HL, but the point is that the transition metal turns colorful, okay? And so the solution does not become darker, it stays the same because you're at equilibrium. You're at equilibrium, and we know at equilibrium. Does anyone know what you see at equilibrium? Is there any physical changes at equilibrium? Yes, no, maybe so. Anything you can see with your eye? Equilibrium, one of the definitions that you need to know for your exam for equilibrium that is really, really stressed in the crash course in the beginning of the teaching of the equilibrium topic is that in equilibrium, there's no visible changes happening. And so the color of solution becoming darker is not part of equilibrium. Okay? That's why A is incorrect. the volume of the liquid decreases. Again, at equilibrium, there's no visible changes happening. The rate of change becomes equal, and you see slowly changes over time, and that's why C is the correct answer. The size of the crystal decreases. No, once again, it's similar to the volume of the liquid decreases. You're not seeing anything to the visible eye changes. It's things that are happening slowly over time, and that's part of the definition of equilibrium. Does that make sense? Hey, question. I want to buy the Bio HL pack for a crash course. The dates are all of March. Good question. So essentially there was a live session of the crash course where we had Zoom session, and you attended the Zoom session and attended as if like it was a live teaching. But now the crash course is over. You can, however, still purchase the crash course, and you have the recordings. And the way it is that like it's like a recording course. So now you go and you press the video and you play the video as if you are in the live session. So you don't get the live session, but you get the video course. So you can still buy the video course, and it's still the same, as like it's as helpful. The only difference is that you don't have the tutor, like you can't ask the tutor questions. But to help with that, what we've created is a Discord channel where when you're watching the video and you have a question, you can just like at the tutor or email the tutor, be like, hey, you explained this in this in the video. Can you explain it again? I have a question. Or can you do this question with me? And that's how we've like essentially tried to mimic the live session for those who are buying the recording. Hopefully that answered your question. Let me know if question 22 is okay and you're happy to move on, or if you want me to re-explain it, guys. But essentially, the point of question 22 is that um, in equilibrium, you have no like changes to the visible eye. Keep that in mind. Okay? Are we happy with that? Can we move on to question 23? Yes? Okay, perfect. 2 moles of NO gas and 1 mole of chlorine were mixed together, and the system was allowed to reach equilibrium at 35 degrees Celsius. Which relationship is correct for this equilibrium at 35 degrees Celsius? Okay, so once again, we have a definition of equilibrium. This is just conceptually um, an understanding of equilibrium. And I'm going to give you a hint. Or actually, I'm going to wait. What should you look at, guys? This is actually such a simple question that can be over complicated in the exam, but it's actually quite simple. I'll give you like 30 seconds to try to guess in the chat. If you don't know what it is, just guess in the chat. Don't worry. We have 7 questions left. Keep up the energy, keep up the interaction, so we can try to finish it as fast as possible. You guys are doing amazing. Anyone have a guess? Just see. Okay. Very good. Whoever's the username heart is eating it up. Oh my god, it's Dalal! Don't play, bro! That is a crash course student. Why did it take me so long to realize it was Dalal? Hopefully I'm saying your name wrong. Right, sorry. Hey! How are you? How's tutoring how's tutoring? How's studying for IB exams going? Guys, Dalal is an icon. She was carrying the chat along with Cedric for bio and chemistry. Okay, we have a C in the chat. Oh, yay. Okay. C, you are correct, Lila. Good job. C is the correct answer. So the way I would do this in my exam is a little hint, guys. You always look at your K value. So if your K value is greater than 1, greater than 1, what does that mean, guys? It means that you have more products than reactants, because your Kc, your equilibrium constant, is just products of reactants. And so if you have a value greater than 1, you have a higher amount of products than reactants, right? Your numerator is much larger than your denominator. And so essentially you're trying to look at which answer option shows that. The only answer option that shows that is C, where it's showing that your products are much greater than your reactants. Does that make sense, guys? Please let me know in the chat. Very good job, Bella. You got that correct. So proud of you. Yes, okay, perfect. Literally, I'm dying, but so far, so good. Okay, I'm glad. Okay, let's have a look at this one. It says, what is the concentration of OH minus ions in the solution at 298 Kelvin with a pH of 4.5? Now, I'm going to tell you something. In your SL syllabus, this is an SL past paper, by the way, you do not, according to the SL paper, according to the SL syllabus, you are not supposed to need to know what POH is. Crash course tutors are like, don't play with us. We know that IB is tricky and they're going to pull this up on the exam. And so we teach SL students POH briefly. We don't go as complicated as HL, of course, but we did teach the SL students POH because we know IB and we know that they're going to pull this shit. And so we taught the students POH, and looky here, look, have a look. And also, we taught it for M25. Thank God we taught the M25 students because otherwise they would have been getting all the questions wrong, the SL students, because it showed up on every single time zone in M25 or two of the time zones. So, trust the crash course tutors, by the way. So POH or OH minus concentration is actually more HL content, but if you're SL, please cover this, please review this because it can show up and it will show up and it has shown up. I'm giving you a warning. Okay, so if your pH is 4.5, we have an A in the chat. Okay, nice guess. I actually don't know if the answer is A. Let me have a look. 24. Oh yeah, it is A. Good job. Okay, good. If your pH is 4.5, how can I get the H plus concentration? They've given me the formula, thankfully. So I can say that 10 to the negative 4.5 is equal to the H plus concentration. And if I have this as my H plus concentration, how do I find my OH minus concentration? Anyone know? I don't I don't know, but I got B, not sure. Don't worry. Okay, let's do it together. So first I found my H plus concentration, which is 10 to the negative 4.5. And that gives me, wow, that gives me a really, really large number, but that's okay. I'm going to keep it on my calculator like this. And I know that Kw is equal to the H plus times my OH minus, right? I know Kw, they've given me that value of Kw. Kw is 1.00 times 10 to the negative 14. And that should equal to the H plus times my OH minus concentration. Okay, I just found out my H plus concentration is 10 to the negative 4.5. And so I just have to calculate for my OH minus concentration. And so I do 1.00 times 10 to the negative 14. And I divide by 10 to the negative 4.5 to get my OH minus. And that will give you a final answer of in my calculator. Yeah, so someone said I just subtracted 14.4.5 and then did this. Yeah, that's exactly the HL. That's the HL way that I was referencing. If I buy both bio and chem crash course, is there a discount? There is not a discount. You get both, but there's a discount now that there's there M2610. You can use this discount. It gives you, I think it's M2610. Have I been giving it wrong? Hopefully that discount code works. If it doesn't, don't be afraid to message me on like DM on TikTok, be like, hey, it didn't work, and I'll give you the correct one. But that's the correct one, and that's a discount code you can use. All right, guys. I think that gives you the answer option A. Okay. Does that make sense? I think Evan was talking about how he got B. Evan, please let me know if that was okay and I can move on. Or if you want, I can re-explain. Because you're doing so well. 5 more questions. Which aqueous solution has the lowest pH? Fire. This is a repeat question. And this has been a repeat question. This has been yeah, for sure. Got this now. Okay, perfect. Nice. This is a repeat question. These are all have been repeat questions that are old syllabus, guys. Also all old syllabus. The one that's new, not new syllabus. This is actually old syllabus content as well, but new in the way that they're presenting it is this one. I'm just telling you now, so you guys also get familiar with IB questions. And yeah. So this has been a repeat. Which one has the lowest pH? If something has a low pH, guys, is it acidic or basic? Who knows? Acid or base? Low pH is very good. Acidic, guys. Nice. So which answer option can I cross out already? I'm thinking in my head, which ones can I cross out? Always think, which ones can I cross out? I can cross out. Which one's clearly a base? D. Very good. Exactly. I'm going to cross out D. Now I have 33% chance of guessing. Now, has a lower pH. pH is dependent on what, guys? Who remembers off the top of their head? If something is a strong or weak acid, strong or weak acid, right? Because we know weaker acids have a pH of like 3, 4, and stronger acids generally have a pH of 1, 2. And so which one is strong? Is ethanoic stronger than HCl? Which ones can I cross out? Is it B? Exactly, B is the correct answer. Good job. HCl, nice. Ethanoic acid I know is weaker. Here I have 1 mole versus 2 mole. Okay? The HCl is much stronger, therefore my answer is going to be B. Okay? Do you guys want me to? Maybe I'll give it to you at the end. There's a hack for how I memorize the strong acids and bases that I give my tutoring students and I give the crash course students, and I can show it to you at the end. I just need a periodic table because there's a really quick way actually to memorize without having to do flashcard decks. What are the oxidizing and reducing agents in this reaction? Okay, What is it? How do I know which one is weaker and stronger? Sorry for this question. I got you, Evan. Stay till the end and I can teach you. Just remind me in the end to show you. Or if you guys want, I can show you now. What would you prefer, guys? Question 26 or show you the trick? Now? Okay, let me show you the trick. All right. So this is what I do. I go up to my periodic table. Uh-oh. I thought there was going to be a periodic table here. All right, give me a second. Bear with me. Bear with me. Oh, it's been a long life. All right, this is my trick to memorize if something is a strong acid or base. Woo. Let's have a look. Okay, so I always do it in the periodic table, so it'd be really helpful if you have your data booklet open to annotate it like this. Okay, so remember that your metals here, your alkaline metals, are strong bases. Okay, what does that mean? It means magnesium oxide, magnesium hydroxide, um, sodium hydroxide, potassium hydroxide, lithium hydroxide. Those are all strong bases. So anything with the metal here is a strong base. Now, also keep in mind that if something has a hydroxide, it's generally a strong base. Okay? Strong base. All right. Next, you need to remember that ammonia is weak. Okay? Anything with nitrogen like this is weak. Ammonium, ethanamide, all those. Anything with ammonia is weak. Anything with a hydroxide and is made up of the two group 1 metals is strong. That's what you need to memorize for bases. Now let's have a look at acids. What do I need to know? My first tip is that all of the halogens form a strong acid, with one exception. HCl, HBr, HI, all the halogens, they're all strong acids. The exception is fluorine. Now, fluorine is too electronegative, so actually HF is an exception and is a weak acid. Okay? What else do you need to know? You need to know that HSO4, anything with H2SO4, anything with a polyatomic ion, HNO3, these are all strong acids. So the halogens, with the exception of fluorine, and polyatomic ions all form strong acids. Hydrogen fluoride is a weak acid. What else is a weak acid? Ethanoic acid. Anything with when you see a carboxyl group like this, COOH, that's a weak acid. And then memorizing based on this, you'll know. So group 1 and group 2 metals, strong bases. Hydroxide, strong base. Anything with ammonia is a weak base. Anything that's a halogen, with the exception of fluorine, is a strong acid. Anything with a polyatomic ion, HNO3, SO4, HPO3, all those are strong acids. Anything with a carboxyl group is a weak acid, and HF is a weak acid. What I like thinking of is if it's not part of group 1 and group 2 and it doesn't have a hydroxide group, it's definitely weak. And what I like thinking of is if it's not part of this list here. Let me show you this list here. Then just assume it's always is a weak acid. Okay? Are we happy with this, guys? Does that help you memorize a bit more? Hopefully you guys annotated as well. You can take a screenshot of this. Okay, hopefully take a screenshot so you guys can keep it and use this to study. Yes, oh my god, wow. Okay, perfect, guys. I'm so glad. This is like the tips. This is why it's so helpful being taught from a student, because students always find like the weirdest way to memorize stuff. That's why it's really helpful to like be taught by a student. And that's why Easy 7 is made by a student for the students, okay? And so hopefully this hack was helpful. It really helps me, and I still use it now to teach the students. And if we're happy, I can move on, okay? Does anybody want me to wait to screenshot this, or can I remove this now? Remove. Thank you guys so much for the 28K likes. We're almost done with the past paper. We have 4 questions left. You guys are doing amazing. I'm gonna remove it, okay? Hopefully you guys, whoever need this to screenshot it. All right, perfect. Let's have a look at this one. It says, which are the oxidizing and reducing agents? Okay, guys, remember, what is an oxidizing agent? Okay, perfect. You took one. That's all that matters. It was your question anyway, Evan. Don't worry about it. Oxidizing and reducing agents. So an oxidizing agent, remember, undergoes reduction. A reducing agent, remember, undergoes oxidation. And so we have to think conceptually of which one's which. So a reducing agent undergoes oxidation. And how can we define oxidation? Oxidation is an increase in oxidation number. Okay, an increase in oxidation number. So I'm looking at here what's happening. I'm trying to find what's going to increase in oxidation number and therefore is oxidizing and therefore is a reducing agent. And then I'm looking at which one is an oxidizing agent, meaning it's reducing and therefore it's decreasing in oxidation number. And so I just have to look and see which was which. So let's have a look at my chlorine. My chlorine here is going from, let's have a look. How do I identify the numbers? First step is to always label the oxygens. My oxygen is always going to be -2. If my oxygen is -2 and the overall charge of this ion is -1, then my chlorine has to be +1. So my chlorine is going from +1 to -1. If I'm going from +1 to -1, that means my oxidation number is decreasing. If my oxidation number, guys, is decreasing, am I undergoing reduction or oxidation? Who remembers? Reduction, very good. I'm undergoing reduction. And therefore, is it my oxidizing agent or my reducing agent? My oxidizing agent, right? Exactly, very good. Oxidizing agent. So my chlorine is my oxidizing agent. Therefore, I'm going to cross out B and C. And then I have the 50-50% chance of guessing. Let's have a look. Let's see what's happening to my sulfur. Please let me know if I'm going too fast, guys, and if you want me to slow down. Ah, okay. I'm getting the messages all now. Yes, good job, guys. Oxidizing agent, oxidizing agent. Nice. I think my internet might be slow. And so then let's figure out sulfur. Once again, step one is to always label the oxygens. I have a charge of -2, but I have two oxygen atoms, so I have an overall charge of -4. If I have an overall charge of -4, the whole molecule's a charge of 0, therefore the charge of sulfur is +4. It's going from +4 to, let's see what's happening. My first step is label the oxygens. I have a charge of -2 coming from the oxygens. I have 4 oxygen atoms, so an overall charge of -8. If I have an overall charge of -8 and my whole molecule is -2, that means my sulfur must be +6. So my sulfur is going from +4 to +6. Therefore, my oxidation number is increasing, and therefore I'm undergoing oxidation, and therefore I'm the reducing agent. Hopefully that made sense, guys. Please let me know if it didn't, and I'm happy to re-explain again. But I hope this question is clear. Okay? Just stop me at any time, and I'm happy to re-explain. I'm going to go ahead and move on to the next one. This is which statement about electrochemical cells is correct? You have primary, you have so you have voltaic cells, electrolytic cells, you have secondary cells. So this is a new syllabus question. Keep that in mind. Why is it a new syllabus question? Is because it's talking about secondary cells. Secondary cells, that was new syllabus content. And so this would be a new syllabus question that you just have to know no matter how many old past papers you've done. You just have to keep that in mind. But SO4 is gaining electrons. Isn't that reduction? No. So it's not about SO4. SO4 is not gaining. Wait, oil rig. Oil rig. Let me orient myself. I don't think it's gaining electrons. I think it's losing electrons. Which past paper is this? This is N25 times 13SL. Careful, not N23, N25. I don't think it's gaining. I think it's losing electrons. I would really recommend for the questions above, don't think about it gaining or losing. Just literally straight up look at the oxidation number. Don't waste your time doing gaining and losing electrons. Okay? Because then that's when you do mistakes. Because I remember I used to also do that step where I just did gaining and losing electrons because conceptually I thought oil rig was easier. But doing so many past papers, like I realized that step that I made silly mistakes. So always just do the oxidation number. Okay? So once again, this is old syllabus. It says secondary cells because it's talking about secondary cells. And it's saying voltaic cells use electrical energy to produce a redox reaction. So they don't use electrical energy. We know that voltaic cells are spontaneous, guys. Hopefully that rings a bell. So remember, voltaic cells are spontaneous, which means they occur naturally. And therefore, what ends up happening is that you actually go from chemical energy, they take chemical energy and convert it to electrical energy. Hopefully that makes sense. So using electrical energy incorrect. They don't use electrical energy. They use chemical energy and convert it to electrical energy. Okay? That's why in a voltaic cell, you have to make sure that you draw a voltmeter. Okay? When you draw a voltmeter, you're showing that you're essentially measuring how much electrical energy you've created. Okay? So this is why this is incorrect. Electrolytic cells are rechargeable. Rechargeable. What does that mean, guys? What is rechargeable? This is a new syllabus concept. Does anyone know what rechargeable means? It's just as we think. It means that you have a discharge and a charging phase. A phase where you're packing up the battery with energy, and a phase where you're using. Okay? Exactly. Emilia said it can be reversed. Kind of. Yes, you're kind of right. Rechargeable can be reversed, where you just keep going through phases of discharge and charge, where you're like adding energy, using energy, adding energy, using energy. And we know electrolytic cells are non spontaneous, okay? And they require energy. So you have to actually use a battery, you have to add energy for an electrolytic cell to happen. And so if I'm adding energy, is it a stable, reversible, rechargeable cycle? No, right? That's why B is incorrect. Okay? Electrolytic cells will just stop working if there's no energy, if there's no battery. Okay? And that's why B is incorrect. Okay, secondary cells can use electrical energy to produce a redox reaction. Yes. Okay, this is true. They are. They do use electrical energy to produce a redox reaction. They are. They do use the electrical energy first of all, and because they use those electrical energy, they produce a redox reaction, and this production of a redox reaction is actually what allows it to be rechargeable. Okay, where you have this electrical energy in the charging phase when you're adding that energy to have a redox reaction, and then it will be reversed in the discharge phase. Okay, that's why C is correct. Now, voltaic cells are rechargeable. Once again, no. Remember, electrolytic cells and voltaic cells are not rechargeable. And when we're talking about rechargeable, we're talking about secondary cells. This is very, very important. This is new syllabus content, guys. So I would really recommend that you review it. And also, more importantly, that you review more specifically the lithium battery. And there was a couple batteries that you need to know. I can't remember them from the top of my head, but there's like a whole subsection of the crash course where we talk about the lithium battery and another one, the lead battery, I believe. I can't remember right now. Anyways, which product may be obtained by the reduction of this? So, reduction of this carboxylic acid. So, when you reduce a carboxylic acid, essentially what's happening, guys? You're creating what? Anyone remember? Thank you guys for 29K likes. We're almost done, guys. We've been going live for like 2 hours and a bit now. We have 3 questions left. Bear with me. We are getting sevens. Yes, we are. An aldehyde, maybe? Okay. So we know that whenever you have a primary alcohol can essentially become an aldehyde, and then it can become a carboxylic acid, right? And we know secondary alcohols can go straight to becoming ketones. Okay. We know tertiary alcohols, they cannot undergo oxidation. And so to reduce a carboxylic acid, you can either create a primary alcohol or an aldehyde. So let's have a look what's happening. Well, first here I see answer option C. I see a ketone, and so it's definitely not C. The reason why I see this is a ketone is because if I draw it out like this, I can see actually. Um, Actually, it's not a ketone even. What is this? This is an not an ester. This is an ether. This is an ether, and that's why C is incorrect. This is an ester. Here, I'll draw that out here. CH3, C double bond O, CO, CH3, like this. Okay, this is an ester, and therefore D is not the answer, C is not the answer, and then I have to choose between A and B. Does anyone notice the difference between A and B? One of them, of course, is a primary, one of them is a secondary, and so B would be the correct answer because I see that it's a primary. Does anyone know how to identify primary acids? Would you like me to go over that or move on? Yeah, exactly. Good job. B is the correct answer. Do you go live randomly or have specific times? So I used to go live every day, and then we had the crash course, and so I didn't have so much time. But I was pretty consistent with going live often. I'm gonna try to be consistent, try to go live every day. I'd really recommend that you like follow our E7 bulletin. You don't have to pay or anything. Just join this thing here because that's where I message. Or just have our live notifications on. I don't know honestly. I go quite randomly, so I apologize about that. But I'm gonna try to be more consistent. And when I'm more consistent with my uni schedule, um, I can give you more specific timing. But it's generally in the evening. And if you join this E7 bulletin, it's free. You don't have to pay. You just press here. I will text you when I go live there. All right. That's why B is the correct answer because it's a primary alcohol. Can you go over that? Of course I can. So primary alcohol essentially just means that the hydroxyl group attached to the main carbon is only bonded to one other carbon. So for example, here is your hydroxyl group. The reason why it's primary is because the carbon it's attached to, oops, the carbon it's attached to is only bonded to one other carbon. And if it's secondary, it means that the carbon it's attached to is bonded to two other carbons. And if it's tertiary, it means the carbon it's attached to is bonded to three other carbons. Which species represents the product of homolytic fission of Br in the presence of UV light? This should be a fire question to get. Who knows? So the product of homolytic fission is what? Does anyone know? We have a B in the chat. It's not quite. Think of product. So this is B is kind of correct, but it's not the product. Very good. Someone said a free radical in the chat. Exactly. Good job. And so which one represents a free radical? D. So this is a really good question to get. Circle it and move on. Which species is an electrophile? So electrophile, electro meaning I like, so phile meaning like, electro meaning negative, like electron, negative like. If I am liking negative, it means I must be what? If I like negative charges, I must be positive, right? And so A is incorrect, B is incorrect, and so I just have to see if it's C or D. Is in this case the alcohol the electrophile or Br? I'll give you a little hint, guys. Exactly. Very good job, Sarah. Very good, Evan. Very good job. Um, if it's an electrophile, am I going to be my reactants or my products in this reaction? Like just to give you like kind of a hint in the exam, what I will be thinking. It's in my reactants. This is a electrophile. Exactly, my reactant. So I'm going to assume that it's Br, and it is Br because I know that this must be the electrophile with a positive charge, and this will be my nucleophile with my negative charge. And I know that my alcohol will undergo essentially this substitution here. Okay, the OH minus will become very, very close to the carbocation of the carbon and then displace the bromine. And that's how we have a reaction between a halogen alkane and an alcohol. And yeah, you need to know you have to have like a really strong base, and you need to have specific conditions like heat and so on in this reaction. All right, perfect, guys. Thank you guys so much for spending this live with me. It was quite a long live, but it was like a good reintroduction back to going live and being consistent. And I really want to be consistent with you guys and provide you with these free resources of going live. If you guys really like this teaching and like our method, I would really recommend to join our crash courses while you still can. Your exams are soon, they're in 20 days. And so now would be the perfect opportunity to join the crash course before it's too late. I mean, of course, you can also just buy it whenever you want, but now would be a really good time to do that, especially if you like our teaching and especially if you're stuck on what you should cover. I really hope this was helpful. Please let me know in the chat if you have any questions about study methods or anything. Thank you so much. This was really helpful. My exam is on Monday. Oh, okay. You're very, very welcome. Sorry, the reason I reacted like that is because I was wondering why your exam is on Monday. Because I know chemistry and bio exams. Oh, some of you guys have exam Monday. Okay, you guys got it. Uh, I wish you the best of luck. If you go on our YouTube, by the way, there's more past paper working out. So if you guys want to continue doing past papers with me. Oh, you mean German? Ah, yeah. Okay, yeah. Yeah, IB exams start literally Monday. It's deadly. But your bio and chemistry and math exams are still in like 20 days roughly. So while you have the opportunity, check out our crash courses, guys. You're a queen. This was super helpful. I'm so glad, Sarah. This was helpful. Um, Once again, guys, I really want to just show you this way. Let me show you this. Um, if you cannot join the crash courses or if you're feeling a bit iffy about it, I would really recommend that you check out our demo. This demo is free, completely free. You just go, you watch the video, see if you like the teaching, see if you like the process. Check out the free resources and you get this for free. So you just press the cheat sheet and you get a whole respiration cheat sheet for bio. And you kind of get the vibe. And if you're liking the vibe of the crash course, I'd really recommend it. Let me know if you guys want me to show you how's the math crash course on Desperate. I can show you a bit about it. I actually was just working on the math crash course resources, and I can show you the resources I was making for math crash course. So if you go to your dashboard, you go to your crash courses, and I go to the math crash course. Here is the math crash course. So this would be where you would see your math crash courses. We don't have the subtopic videos yet, but if you go here, you have the full day recording, and you can just watch it as if you're watching the. Good night, Evan. Thank you so much. You're very welcome. I'm gonna post this live on YouTube as well if you want to watch the beginning, because I know you missed the beginning. Anyway, so here's the full day recording. My internet's horrible, so it's loading. But essentially, this is where you would get the full day recording while it's loading, and you can watch it on 2x speed. And this is how. Let me show you. For example, if you go here, you have your day one resources. This is the slides of the crash course. Sorry guys, it's been a long day. Your resource pack, you have topical practice questions, and as usual, let me know if you want me to be more specific and show you the actual slides. And then you have the additional resources as well. Let me show you, for example, I just created these cheat sheets for math. So this is the binomial distribution cheat sheet that I've created, for example. And you'll see here, like it tells you exactly what you should do if the question says exactly X, or at most the probability of this, or at least the probability of this, or more than this. This is exactly what you should write on your exam, and exactly what you should plug in your calculator, and every single type of binomial distribution question that can show up. And so that's kind of the vibe of the math crash course. Again, for normal distribution, and so on. Maybe I can show you the slides. Here actually is an example of the topic 4 slides. I just have them up. And we cover every single thing that you need to know. And the way we do it is that we cover content, and then we do sample practice questions with you, and then we cover IB questions. And then it's content, and then sample questions, and then IB questions with you. And that's how kind of the slides look. And of course, you have access to past paper analysis, just like you do for anything. You have the syllabus guides, you have notes, and so on. Did that answer your question about how math was? Does anyone have any other questions about any other crash courses they want to see something before I go for today? You guys did so well. Yay, thank you. I'm glad. Okay, perfect. Um, yeah, so topic 4 slides, the resource pack. It's kind of the same. And you'll see here, for example, if you go to the trigonometry paper questions, you just have like a list, insane amount of IB questions, 75-page document of paper 1. And you also have this type of ultimate question pack, which is essentially just like also just compiled IB questions along with the recordings of the crash course and the other resources. Does anyone have any questions? If not, that's all for today, guys. It was a really long live, so sorry if I'm getting a bit tired towards the end. It was a 2-hour live, but I really hope this was helpful, and I hope you guys enjoyed this. I'm just going to stay a bit longer in case anyone has any questions. And of course, you have, by the way, the syllabus checklist and the outlines and all the guidelines, essentially how you should study for your exam. Thank you guys so much for 30K likes. You guys are the best. I think we're going to go live again tomorrow. Do join our bulletin. I'm going to now upload this, by the way, on that drive link. Kind of overloaded you with information, but remember that. Where's my cast? Remember that if you join the E7 bulletin, here, which is completely free, that's how you're gonna know if I go live, because I just text there and I do polls of like what past paper I should do. And also, if you scroll up all the way to the top, there's that link of that drive, which is also free. Don't worry, which is just like the drive of all the annotated past papers. And now I'm just gonna export this document here and put that on that drive, so you guys can have access to the annotated document as well. Okay. Remember that the discount code for the crash courses is M2610. And that is all, guys. I really hope this live session was helpful. I'm going to go download the video now and upload it straight to YouTube. And that was it, guys. All right. Good night, guys. I really hope this was helpful. Bye-bye. You're very welcome.